Good morning, sir. Good morning, sir.
Good morning.
So right now we have 43 participants right now joined with us. Sir, good morning, sir. Sir, we have given you the presenter rights, sir. Hello, Ratnajit, sir. Good morning, sir. Good morning, sir. Am I audible? Okay, thank you, Chintan, sir. Ratnaji, sir, good morning, sir. Hello, Ratnaji, sir. Can you hear me, sir? Hello, Ratnaji, sir. Can you hear me, sir?
Good morning.
Good morning, sir. Sir, we have made you the presenter in the meeting, sir. So we request you to please share some slides.
Good morning.
Yes, sir. Good morning, sir. Sir, you are audible and visible, sir. Can you hear me, sir?
Yes, Aditya, I can hear you. Very good morning.
Good morning, sir. Sir, we have given you the presenter right, sir.
Ma'am.
So,
Participants are already there.
yes, sir. Total 97 participants are online, sir. And and gradually the number is increasing, sir. So, with your permission, sir, shall we start?
Yeah, we can start the session because it says 1 hour this thing. So
Okay, sir. Okay, sir. So, dear participants, good morning, all. And we welcome you in this last day of 2 weeks long joint faculty development program on IoT and applications in smart systems. So on behalf of all the organizing E and ICT academies at IIT Guwahati, NIT Patna, IIT Kanpur, MNIT Jaipur, IIT Roorkee and IITM Jabalpur, I welcome you all. And today's first session will be taken by our expert, Professor Ratnajit Bhattacharjee, sir, from IIT Guwahati. So, sir, I welcome you on the platform to deliver lecture number 15 on 5G and IoT. Over to you, sir.
thank you, Aditi. And possibly this is the last lecture, and thereafter I could see in the schedule there are some hands-on. So I will keep my video off and go to the slide sharing mode. Please feel free to interrupt whenever you have any queries and all. And in between, please respond so that I can understand you all are listening or whatever I am presenting is visible to you. Is my slides visible?
Yes, sir, it's visible, sir.
So let me go to the full screen mode. So the topic of today's discussion is 5G and IoT. In this particular FDP, we were discussing different aspects of IoT, and we understand that Internet of Things that is going to actually connect different devices over internet to provide a set of services, and different applications can come up. Now, IoT traffic has to be carried through a communication network. And in my first day talk, we have discussed different communication technologies which can support IoT. Please note that this communication can take place through network and using frequencies which are in the ISM band, and depending upon the distances, some of the proprietary technologies can be used. But one thing is that last several years we are hearing this buzzword 5G, which is going to drastically change our communication scenarios. So in this brief talk, we try to explore what is 5G and what 5G means for IoT, and how it is going to cater to the requirements of IoT. Am I audible, Aditi, clearly?
Yes, sir, you're audible, sir. It's clear.
Yeah, and slide also you can see.
Yes, sir, we can see the slides also. It is perfectly clear, sir.
Okay, thank you. Now, because
Thank you,
I
sir.
am connected right now from my quarter where the bandwidth at times give problem.
Okay, so we will let you know if any
Yeah,
problem arises.
yeah.
Thank you.
So let us try to first see. We know that there are different telecom players, international players. So what 5G means? What is 5G? So if you go by Ericsson's website, 5G is the fifth generation of cellular network, up to 100 times faster than 4G. 5G is creating never before seen opportunities for people and business. So this is very important. It is creating never before seen opportunities for people and business. So I'll explain later. If you go by Qualcomm way of describing 5G, 5G enables a new kind of network that is designed to connect virtually everyone and everything together. So same thing we told about IoT also, huge number of devices connected together, including machines, objects, and devices. So that means 5G has provision for connecting machines, objects, and devices. If you go by Verizon, Verizon has recently deployed the 5G services in US very recently. It can provide higher speed and lower latency. Latency is the delay, and this will play a very important role, particularly designing IoT type of services, which are targeted to become almost real time. There are specific applications where delay cannot be tolerated, and greater capacity than 4G LTE networks. It is designed Cisco's way It is designed to increase the speed, reduce latency, improve flexibility of wireless services. 5G technology has a theoretical peak speed of 20 Gbps, while peak speed of 4G is only 1 Gbps. So these are the different views about 5G, and 5G has become, the word 5G has become very, very popular. And you go to any part of the world, at least a large number of people will respond there. They have heard of 5G. So coming to little bit technical way of telling what 5G, yeah, it is, although normally we try to refer anything, any activities beyond 4G or LTE networks as 5G. Specifically, what 5G means, fifth generation wireless system actually refers to technologies that satisfy ITU IMT 2020. So requirements and 3GPP release 50. So these requirements are a set of requirements which have been specified in their respective releases, IMT 2020 and 3GPP release 15. So ITU, as you know, it is a specialized agency of UN responsible for all matters related to information communication technology, with 193 member states and many other members associated from industry and academia. And International Mobile Telecommunication 2020, which is called IMT 2020 standards, are the requirements issued by ITU, radio communication sector, ITUR, in the International Telecommunication Union, ITU, in 2015 for 5G network devices and services. So this talks about what is IMT 2020. So it is a set of specification and recommendations. Similarly, there is another body called the 3GPP, Third Generation Partnership Project, and it unites 7 telecom standards development organization. Our Indian Telecom Standard Development Association, TSDSI, is also a member to it. And 3GPP split the 5G standard into 2 releases. 5G 15, which corresponds to new radio phase 1, and release 16, which corresponds to new radio phase 2. And they are also coming up with the release 17. So these are very elaborate technical documents specifying what should be the wireless communication in this current generation. And this is actually, you can say that there are international telecommunication and also a consortia of standardization bodies are involved. They lay down the specification and details. So altogether, this is 5G, any technology which is conforming to these recommendations, we call it 5G. So 5G is not just a terminology which talks about any, for that we use the next generation technology, but 5G is very specific. So telecommunication, it evolves very rapidly, and starting around 1980s, we have, by 2022, we have gone through 4 generation, and we are at the verge of entering the 5th generation. So 1G, it is the analog telephone phone calls, and it was the first mobile services. So the key differentiator was mobility, but the issues it's addressed by subsequent generation is its poor spectral efficiency, security issues. Second generation is where the technology matured and it is digital phone calls and messaging. GSM, in fact, became the standard for mobile communication all over the world. It is secure and mass adoption, but the data rates were limited and the services also were limited to only voice and text. 3G, the phone call messaging and data, better internet experience, broadband. 3G created a lot of hype, and actually CDMA based technologies were introduced, but the real performance did not match the hype. Then came the real broadband service, what we call long-term evolution or LTE services. And currently 4G is being deployed, still parallelly being deployed in different parts of the world. Like in India, if you go to different parts, many places 2G, 3G services are available, 4G services are being introduced recently. So 4G is still there. It is IP-based services, faster broadband and lower latency. And then I put a question mark, what is next is 5G. That is what we are going to see. How 5G is going to change or what additional changes it is going to address as compared to its predecessors and what we expect from this new technology. So let us try to see the technology features, key technology features, and the technological evolutions that will make 5G possible. And then we will discuss this in the context of IoT. So one of the services which is promised by 5G is, it is called EMBB, Enhanced Mobile Broadband. This is actually can be thought of as improvement upon 4G services in terms of your data connectivity, voice connectivity, and all. So it is enhanced mobile broadband. But additionally, what it supports, this is called URLLC. You might have come across this terminology in some of the previous talks. Ultra reliability and low latency communication. See, telecom network is actually try to carry information from source to destination. In between, it encounters different channel conditions, and the signals may have to travel to different uh, types of channels, and the characteristics of the channel and all they affect. For example, if it is a wired channel, you know that the only source of disturbance is that of noise. But when you go it wirelessly, there are many other physical phenomena comes into picture, which is called fading, multipath, delay because of Doppler and other things. Now, reliability, we try to mean that how much of data you are being able to transfer without losing information. And for that, different technologies have been developed to improve the reliability. But when you try to improve the reliability, maybe you will have to, in some cases, for example, very reliable these things is a guaranteed delivery. It is achieved through retransmissions. But if you go to a retransmission type of scenario, uh, your time will actually increase and your latency will increase. So there are several issues which are involved. And then the third type of communication, which 5G is going to uh, support, is massive machine type communication, or MMTC. So these are the three broad services what is expected from 5G and how these are going to be provided. So 5G will not be a single technology. It requires improvement and different uh, segments and different technologies. First is the radio access technology evolution. You know that in wireless system, it is the last mile which is wireless, and then from your base station to another base station, it goes through different types of link, either fiber or LOS microwave or even satellite. So radio access technologies need to evolve. Then hyperdense small cells. So this is another development. It has been shown that if you can have smaller cell sizes and you have large number of such cells, then the capacity can be improved. Self-organizing network. This is another concept because you need to be aware of the environment when you are using smaller cells and large number of small access points or base stations operating. They should operate in a coordinated manner without creating any interference with the neighborhood. Machine type communication. So this is something which 5G includes. Uh, you can have the scenarios where at both ends of the devices communication link there are machines, and we'll talk more about it. Millimeter wave rate. So far the wireless communication services has been provided using frequencies near, these are called sub 6 gigahertz. Some cases in Wi-Fi and all, it may go as high as 5 gigahertz. But in cellular, it is 1800 megahertz, 900 megahertz. ISM band services are 2400 megahertz. So these are lower microwave frequencies. So why these have been used? Because it gives longer coverage, higher penetration, because ultimately your signal has to penetrate through building walls and all, and also should not be scattered by objects. So lower frequencies, lower microwave frequencies are found suitable than the very high frequencies. But what has happened actually, when you try to push higher and higher data rates, you require higher and higher bandwidth also, um, because the capacity theorem, if you consider, for example, a network capacity is proportional to B and logarithmically proportional to signal by noise ratio. So if you can have higher bandwidth, you can have higher capacity. But higher bandwidth is available if your center frequencies or carrier frequencies are taken at a higher level. So millimeter wave frequencies are coming into picture. In India, we are trying about 26 gigahertz is being experimented, 28 gigahertz is being experimented. Then 5G new radio, it covers frequencies, even higher frequencies, 39 and 40 gigahertz. So there actually you can have very large bandwidth, up to 400 megahertz single channel bandwidth is possible. And that will be useful in supporting the enhanced broadband services. But the issue comes elsewhere. The moment you go towards higher frequencies, your range reduces, your Doppler frequency increases, signals cannot penetrate. So the technological development is taking place to accommodate millimeter wave technologies. Then redesign of backhaul network, as I told, the backhaul network plays a very important role. The connecting the base stations through very high speed fiber network. So densification of optical fiber network is also very, very crucial to have widespread 5G coverage. Energy efficiency. So when you have IoT type devices operating, uh, they will need to communicate information, and if you can transfer energy, information using spending less energy, your network lifetime or device lifetime will increase. So energy efficiency is going to play a very crucial role in 5G, and it is documented in the specification. Allocation of new frequencies, this is also very, very important. People are exploring not only higher frequencies, like in India, recently Airtel has conducted an experiment near Kolkata at 700 megahertz to demonstrate long distance high data rate connectivity. So these are important, particularly in the context of rural coverage, where you have a sparse population and with a single base station, you try to cover larger distances or larger areas. So new frequency bands are being experimented at present in Indian context around 3.3 to 3.6 gigahertz in the sub. This is being allocated, but other frequencies are also under consideration. Spectrum sharing and RAN virtualization, radio access network virtualization, cooperation among operators, all these things comes into picture. So these are the, you can see the supports on which 5G will eventually evolve. And this is based on the reference by Jonathan Rodriguez book. Now let us try to see. Aditi, can you see the slides and am I audible?
Yes, sir. The slides are
Yeah.
visible and you're audible also.
Okay, okay. So enhancement of key capabilities when it comes from IMT advanced, which is 4G, to IMT 2020, which is 5G. And please look at this color codes. IMT 2020 is advanced is in blue and the other one is in near red color. So peak data rate is expected to grow from 1 Gbps to 20 Gbps. This is a massive increase. People also talk about, so peak data rate is the data rate that can be achieved under idealized condition, but in practical scenarios, the data rate experienced by the user is going to depend on many other factors. So the IMT 2020 also talks about user experience data rate, which is presently in 4G, it should give you about 10 Mbps to 100 Mbps, so 10-fold increase. And then spectrum efficiency. Spectrum efficiency is a term which is measured in bits per second per hertz. That means how many bits you can send per second using 1 hertz of frequency. So it is going to increase at least threefold with 5G. Presently, so this spectrum efficiency in the uplink and downlink, these are that can be achieved are different, because in the uplink, the device that is your mobile device or other devices, handheld devices that are transmitting. In the downlink, it is the base station is transmitting, which is rich in resources. Then mobility, it of course talks about the peak mobility, because many services are being planned in high-speed vehicles, trains, and other. So at present, it can support 350 kilometer per hour to 500 kilometer per hour. This is targeted. Mobility, what it does, as you know, that the channel, when you have a highly mobile system, then it introduces what is known as Doppler shift. And we talk about, in wireless communication, we talk about one time, which is called the coherence time. And it is related to, inversely related to the Doppler spread. Now, why coherence time is important? Because this is the time when the channel conditions are seem steady. So if your coherence time of the system is large, you can send packets, plan sending of packets within that coherence time. Whereas if your coherence time is very small, then the channel will change in between, and recovering the bits becomes very difficult. So mobility also plays an important role in design of the systems. Latency, I have already talked that latency is the delay that you can the network introduces while carrying the traffic. And at present, the latency is about 10 millisecond, and 5G, through different technological advancements and sophisticated processing algorithms, would like to bring it to a latency of 1 millisecond. So this is the target. Connection density, devices per kilometer square. This is also important, because IoT, whenever we are talking of billion devices, and maybe in certain regions, the number of devices that are going to be connected will be very high, and they will coexist with the other mobile devices the users are carrying. So connection density is the devices per kilometer square. It should increase tenfold in 5G scenarios. Then network energy efficiency, I've already mentioned that it should, 5G is targeting 100-fold increase. This is a very, very big ask. And so very low power communications, and also processing has to be done in such a way. And area traffic capacity, this is of course uh, of interest to the operators, that how much traffic capacity they can support. So overall, you can see that from existing 4G, 5G is going to provide you in all parameters drastic improvements. Of course, these are the target sets and different technological means are being explored to achieve those targets. So how a 5G architecture will look like, this is important, because the technologies, it is expected at the heart will be MIMO, massive MIMO, 3D MIMO, different terminologies are used. And then you can see that there are millimeter wave radio access technologies will be there, hyperdense small cells, then smart grid, people are talking of even your power grid will become smart and will get interconnected. Cloud computing, lot of computing will be done at the cloud and supported through 5G. Wi-Fi offloading. So many local needs will be actually serviced through good Wi-Fi network if it is present. It has already started from 4G itself, that whenever traffic is to be delivered, if the network condition is not good, it takes the alternate Wi-Fi network path to deliver the traffic. There will be intelligent user equipment, public safety devices, relay. This is another concept which are being used for quite some times to provide range extension as well as uh, providing reliability, improving diversity. So relaying techniques has been used. Native support for machine type communication, other IoT devices. A very important feature that is going to come is D2D services. Already it is there in some forms, and D2D, device to device, direct device to device communication. Instead, this device going through the base station transfers data directly. Now, this may be in band or outside the bandwidth. It may be underlay mode or overlay mode. So different configurations are being uh, tried. So at times it may be with the same band of the cellular frequency band, or at times it may be this for D2D communication, specific frequencies may be assigned. So D2D communication is going to play a major role in IoT type scenarios, and 5G is going to support device to device communication directly. Another area, already I think there has been some uh, talks. We are talking of ITS or intelligent transportation systems and V2X type of scenarios, vehicle to everything, because IoT is promising, say, driverless vehicles and many other advanced scenarios for which the case studies are being built. So machine to MTC type communication, V2X type of communications, if they are not supported by 5G, then 5G network cannot be used for this type of purposes. So MTC, V2X, D2D, these are integral part of a IoT solution. So 5G system architecture, as we can see, has enough room for supporting IoT type communication. Now, how it is going to happen, 5G deployment and adoption. Like if you take Indian scenario, in India, it is expected 5G will roll out in certain select cities. I think in some 13 cities have been identified. Expected rollout is around 2022, and a lot of case studies are being tested. The testing has been done near Noida, in Pune, in Kolkata, and three major telecom service providers, operators in India, Jio, Airtel, and Vodafone. They are carrying out experiments and case studies pre-rolling out, and government has given them some test frequencies where they can actually build those case studies and test. So deployment and adoption, it depends on many factors. First is it provides opportunities, EMBB and FWA, IoT and D2D. Fixed FWA is another access technology. It is called fixed wireless access. So high broadband access through 5G network, uh, primarily targeted as a competitor for your say cable type of network services. IoT and D2D transformation of several verticals and future developments. Of course, one of the major consideration will be the cost consideration. Then other considerations will be heterogeneity. Now we can see that 5G is going to support heterogeneous type of services, and there should be enough flexibility, and automation makes 5G different from previous generation. Cost dynamics will be influenced by factors other than capacity and coverage. So the network deployment cost will not only be dependent upon the capacity of coverage, there will be many other factors. And some of the dependencies for deployment and adoption is technology readiness, that is done through standards and devices. For last decade, people are working, developing the standard devices. Policy work, spectrum availability. Now, these are some of the issues you might have very recently you might have read that there was some issues in US when Verizon started deployment, interference with the aircraft navigation system. So these issues are there. What spectrum is available and how you allot them. Of course, pricing is another issue. Regulatory issues are there, and market conditions. So all these things will actually depend on how fast 5G is deployed and how IoT services can take advantage of 5G deployment. So we have already told that it will provide you three generic services with vastly heterogeneous requirement: EMBB, MMTC, and URLC. Service heterogeneity can be accommodated by network slicing. So how 5G is going to provide this? through which each service is allocated resources to provide performance guarantee and isolation from other services. So for more details, you can refer to this reference, which is published recently. Going quickly through some of these, EMBB is required to support stable connection with very high peak data rates as well as moderate rates for cell edge users. So when we are talking of the edges, there the data rate you will not get the same peak data rate. And EMBB traffic can be considered to be a direct extension of 4G service characterized by large payloads and device activation pattern that remains stable over an extended time of interval. So how many devices are active in the network or part of the network? It is more or less stable, and it allows network to schedule wireless resources such that no two EMBB devices access the same resource simultaneously. So you can actually look at resources, and objective is to maximize the data rate while guaranteeing moderate reliability with packet error of the order of 10 to the power minus 3. So these are some of the characteristics of EMBB. But as you will see, the characteristic changes drastically when we go for other two services, machine type and URLLC. So MMTC supports a massive number of Internet of Things devices which are only sporadically active and send small data payloads. Sorry, there is a typo. I'll correct it. And MMTC device is active intermittently, uses a fixed, typically low transmission rate in the uplink. So most of the time, these IoT devices are in the sleep mode. They wake up whenever they send some changes and transfer data. So there may be a large number of MMTC devices connected to a given base station, but at a given time, only an unknown subset of them, which is random in nature, become active and attempt to send data. So large number of potentially active MMTC devices make it infeasible to allocate a priori resources for individual MMTC devices. So you cannot make allocation before because you have very large number of devices. And what is more feasible is to go for a random access type, that you keep some resources allocated for MMTC type of devices, and they will random access, they will get access to these services. Now, MMTC type of services will constitute most part of the IoT services which are being planned. And the size of the active subset of MMTC device is a random variable. Average value measures the traffic arrival rate, because network will have to know what rate traffic is being arriving. Please try to understand from the 5G network point of view. It will have to allocate resources for the services. An objective in the design of MMTC is to maximize arrival rate that can be supported in a given radio resource. And packet error rate targeted in this type of services is typically low. When it comes to URLC, there the number of devices asking for this type of services may be much lower than MMTC type of services. limited set of terminals, but they will ask for very high reliability. That means bit error rate should be very, very, or packet error rate should be very, very low. And at the same time, that is to be provided with very low latency. Now, most of these fancy applications, which IoT based applications, which are being thought of, like several virtual reality application, gaming application, or even uh, real-time control of devices, robots, instruments, they will actually require this type of services. And these transmissions are intermittent, but the set of potential URLC transmitters is much smaller as compared to MMTC. And supporting intermittent URLCC transmission requires a combination of scheduling. You cannot make them purely random access, because in order to ensure certain amount of predictability in the available resources and thus support high reliability. Because if you go for move towards more towards random access type services, the reliability and the latency you cannot support, as well as random access, in order to avoid too many resources being idle. Because once you allocate the resource and if it is not utilized by those devices, then underutilized resources become large and it adds to the overhead of the network operation. So diversity, which is critical to achieve high reliability, can hence be achieved by using multiple frequency or spatial resources. The rate of a URLC transmission is relatively low. Main requirement is ensuring high reliability level with a PR typically lower than 10 to the power minus 5, despite small block length. So these are the requirements which are to be supported by 5G in terms of IoT requirements. So sharing of wireless resources. Wireless resources means the frequency, time slot, power, all this in 5G types is an important issue. And as we have mentioned, network slicing allocates network computing, storage, and communication resources among active services with the aim of guaranteeing their isolation and given performance level. And now, conventional methodology of getting access to these services, it is called orthogonal multiple access, or OMA, which allocates communication resources to different users orthogonally, at least in one radio resource dimension, either frequency, time, or code, and it has been widely deployed. Recently, people are talking of non-orthogonal multiple access, or NOMA, where the same band of frequencies at the same time can be used, and it is distinguished based on the power level, but it requires use of superposition coding and successive interference cancellation, SIC. So these are upcoming trends, how you can allocate resources to different services, EMBB, MMTC, URLLC. And then people are also proposing very as hybrid schemes. So in this brief talk, actually, I have tried to connect these two latest developments, IoT and 5G, and explain what are the different services which 5G has to support in order to allow deployment of practical IoT systems. And with this, I conclude this talk, and thanks for your attention.
Thank you, sir. Thank you for this wonderful presentation. So now I request all the participants to please let us know your queries by posting it in either in the chat or Q&A section, or else you can also raise your hand so that we can unmute to you from the host end and you can interact with the expert. Dear sir,
Yes.
there is no questions from the participants, sir, I guess.
So, how the hands-on are going on, Aditi? People are
Yes,
taking
sir.
part in that.
Yes, sir. Today now the hands-on session 9 will be taken by Jitesh Kumar, sir. And participants are very participative in the hands-on session also.
And there is one question I could see, that what is the future of 5G? See, wireless communication is evolving. As I told, 5G actually is a set of recommendations given by ITU and 3GPP. Now, well, 5G is under deployment in different parts of the world with different case studies and services. People have started already exploring the next generation of services, what people call 6G services. And as the network becomes larger and larger with many number of devices, users connected, the resource allocation policies, network management, all these things are coming under, because these are done based on certain algorithms, certain heuristics at some times. Now, in recent times, we see a lot of AI based things are getting into artificial intelligence, machine learning. These are gradually entering into uh, as dominant techniques for design of next generation of systems, making system intelligence, and also simultaneously another drive is going on, because wireless communication services are provided, it consumes a lot of energy as well, and carbon footprint is a major issue. So developing low power greener technologies are also on the radar. And in fact, IoT, 5G or 6G, everything will have to evolve towards that direction.
Thank you, sir. So there is one more query from a participant named G. Krishnaveni.
Hmm.
So she's asking, what is the role of RF section, mainly antenna design in 5G?
Antenna design plays a very critical role. As you know that already at the lower frequencies, the design has become standardized. As we go to millimeter wave frequencies, assuming that the form factor of the devices do not change, you have much larger space to design arrays, and that essentially is going to take care of the signal loss that occurs because of the higher usage of higher frequency. So individual antennas will be replaced by arrays. But when you design arrays, in that case, actually, it becomes directional. In other way, it can hear or transmit in one direction very well, other direction it becomes deaf. So if you want to cover all around, then you will have to have the capability of steering the beam. So this type of flexibility is given by designing beam formats, where by changing weights, you can create multiple beams, you can throw beam in your desired direction, or you can steer a beam. But if you try to do it in using conventional method, then each antenna has to be connected with a RF chain. So hybrid beamforming is another area which is under active consideration. And antenna element design, of course, what type of element one should design, what is the power level at higher microwave frequencies. These antennas will not be operating in an isolated manner. These are to be integrated with the other part of the electronics on a substrate. So losses, integrability with the silicon or other type of substrates for making an integrated system. These are, of course, the challenges.
Thank you, sir. Thank you for solving all the queries,
Thank
sir.
you. Thank you.
Sir. So thank you for joining.
Okay.
Sir,
I disconnect now.
Yes, sir. So the valedictory session will be from 2.
I will have to possibly join on mobile because 2 o'clock actually, I have some other. I'll try to be present through mobile, huh?
Okay, sir. Okay, sir. Thank you, sir. Thank you so much for joining.
Thank you.
So dear participants, we will now start with our hands-on session 9, which will be conducted by IoT Academy. So from IoT Academy, we have Mr. Jitesh Kumar with us right now. So he will be conducting the hands-on session 9 till 12 o'clock. So Jitesh sir, we are making you the presenter.
Yes, ma'am. So screen is visible, ma'am?
Yes, sir. The screen is absolutely visible, sir. Thank you.
We can start?
Yeah, we can start.
Okay. So, good morning, everyone. And this is in this headphone, we will first learn about the MQTT protocol. So, there are some prerequisites we have to understand that the hands-on part we will start in after 12:30. So, from 11 a.m. to 12 p.m. we will understand some basic protocols and we have to install some prerequisite software in this. So first we will start what is MQTT, why we use MQTT, what is the MQTT protocol, and what is publish subscribe model. So anyone, can you tell me what is publish subscribe model? What is publish subscribe model? Anyone, can you tell me? Can you write publish subscribe model into the chat? What is publish subscribe model in IoT? Anyone? Anyone, can you tell me? I think there is no. Okay. So in the publish subscribe model, there is a publisher and there is a broker. So So see here, everyone. Yes, yes. So there is a broker. This is the broker. And you can imagine this by an analogy. Imagine there is a, this is my jewelry shop. Imagine, this is my jewelry shop. You can understand by this analogy. And there are some people, they are giving me price. Every day in the morning, they are telling me the price. So there are two persons, P1 and P2. P1 is telling me every day the price of the gold. Similarly, P2 is telling me every day the price of the silver. Every day at 10 a.m. they will tell me that what is the today's price, and I get the price. Then there are some shopkeepers or some customers are there, and these are the S1, S2, and S3. These are customers or shopkeepers, and they are, this S1 is interested. What is the interest of S1? S1 is interested only into gold. S2 is say I interested only, so I interested both in gold and silver. I interested in both. And S3 say I interested only in silver. So whenever I will get price from P1 and P2, I am a broker. This is my jewelry shop. I am broker. When I get the price, imagine the price is 50,000 and silver price 70,000 per kg, and this is 50,000 per 10 gram. Then I will tell to price to S1. This is the price. This is the price, gold and silver. This is the price. Same price I am telling you. So I am acting as a broker. So same thing, same scenario is available into the MQTT. So in the MQTT, these are called, who send the data? These are called the publisher. In MQTT, these are called the publisher, and these all are S1, S2, these are called the subscribers. Like you subscribe any YouTube channel. So when anyone posts the data, you will get the notification of the data. So similarly, the YouTube is acting like a broker. Similarly, in the MQTT, there is a broker. So the broker will get data from the publisher. Then broker will distribute data according to their interest. Distribute data to the subscriber according to their interest. So this gold, silver, these are called the topics. These are called the topics and actual data. This is called the payload. 70,000, 50,000. This is the actually payload. So broker will distribute according to their interest of subscribers, and broker can also store the data. So there are a lot of types of broker available in the market. So we will also install the local broker. Means broker on our system. We can install broker on our system, and there is some brokers that are available onto the cloud. So this scenario, there are publisher, subscriber. Publisher and subscriber don't know the existence of each other. They even don't know. P1 don't know if there are S1, S2, S3, and similarly S2 don't know there are a P1 or P2. They cannot contact directly, because in middle there must be a broker. So this type of scenario, this type of analogy is in the MQTT protocol. Is it clear to everyone, this thing? Is it clear to everyone? So same thing is here in MQTT. So now introduction to MQTT. MQTT stands for Message Queuing Telemetry Transfer Protocol, and MQTT is a client server publish subscribe messaging transfer protocol. It is a publish subscribe, publisher, subscriber, and broker. It is a lightweight, open, and simple, and designed so as to easy to be implemented. So these characteristics make it ideal for use in many situations like constrained environment, when there is a less amount of RAM, when there is a less amount of ROM, when there is a less less number of lines of code you have to write. There is small processor, there is more RAM. You have constrained environment in which you have to send data to the cloud. That time you can use the MQTT protocol. MQTT best for constrained environment. Please everyone, HTTP is not suitable for constrained environment. When there is a less amount of RAM, less amount of ROM, there is a small microprocessor, 8-bit processor, from which you want to do work with IoT work, then you can use this MQTT protocol. So MQTT is also being used as underlying communication protocol for IoT and industrial IoT architecture. MQTT is used in smart home automation system alongside with cloud firms like IBM, AWS, and Microsoft Azure. Facebook also MQTT as a communication protocol for its Messenger and Instagram platform. And it is also used in industrial IoT, because in the industrial IoT, like where there is a manufacturing industry, mining, oil and gas, there are lot of massive number of sensors are there, and the sensors are sending data to analytic engine. That data is telemetry data. So now there are lot of sensors, and they are sending data to the analytic engine. So in analytic engine, we are analyzing the data for trends, for anomalies, and we will, why? Because we have to enable the organization to better understand and improve their operation. So in such type of environment where there is a lot of data, so by using LP1 technology, we can send data to wireless radio transmission, and where the data is received by a central base. So this data actually is small in packet, but massive. Data is small, but there are a lot of packets. So when we aggregate it, so then we send to analytics for visualization too. So there is a case, the MQTT, because it is on to the top of the TCP/IP network. So MQTT lightweight published subscribe message protocol designed for low bandwidth, high latency, and unreliable network. When there are a lot of sensitive data, you have to send. There is a small amount, but a lot of data. That time this is best for when it is an excellent option for sending high volume of sensor message to analytic platform. The number of data is low. You can say massive number of data. So it is lightweight binary protocol, and due to its minimal packet overhead, MQTT excels when transferring data over the wire in comparison to like HTTP. Another important aspect of protocol MQTT is extremely easy to implement on the client side. There is simpler implementation, quality of service data delivery means guarantee of the data should be lightweight and bandwidth efficient, data agnostic, and there is continuous session awareness also there. And MQTT is invented by 1999 by two engineers. The NG stands for Clark and Orland Ripper, as a method of aligning pipelines in the oil and gas industry to communicate with SCADA systems. So at the time, these systems use disparate proprietary protocols. We are not able to communicate with each other. Adding MQTT capability has overcome intercommunication problem. So in addition to interoperability, the original goal for the protocol was it should be lightweight, bandwidth efficient, and data agnostic, and simple to implement while offering quality of data service. So it should be implemented simply. So the publish subscribe model, also known the PubSub model. So the client server in the client server model, client communicates directly with the endpoint. Where in publish subscribe model, it decouples the client that sends the message and the client that receives the message. Once there is a decoupling between publisher and subscriber, they never contact publisher and subscriber. They never contact each other directly. They have to communicate using the broker, and the connection between publisher and broker handled by the third component, that is the broker. Broker is the main component of publish subscribe model. So what is the job of the broker? To filter all incoming message and distribute them correctly to the subscriber. So like here, there is a MQTT broker. There is a humidity sensor that is sending data to a topic. That topic is a humidity, sending data 32% humidity. So it's sending to the broker. In this, there are two subscribers. There are on-premises analytics and cloud analytics that are getting data from the broker. But before get the data, they have to subscribe on the topic. Their subscription is on the basis of the topic. So the topic is humidity. So humidity sensor sending data to MQTT broker. That topic humidity. Same topic should be subscribed by the on-premises analytics or cloud analytics. So the same topic is humidity. Then broker will send data. When it receives data on the same topic, the broker will send data to the subscriber. Similarly, again, if there is a car, there is a sensor, and sensor is sending data, the speed of the car. So the topic is speed, published to topic, that is speed to the broker. Now they both are subscribed to the broker. These are mobile device and backend device. These both are subscribers. They subscribe to the broker on the same topic. The same topic is speed. So now broker will get the data. So broker will distribute data according to their interest. This type of service also, this is the publish subscribe illustration, and this is also publish subscribe model. The feature of PubSub model, decoupling, no direct communication, scalability. So this is the part. Scalability is the part of the broker. How broker distribute the data, and because broker will receive a lot of data simultaneously. So it is the message caching and intelligent routing of message, often decisive factor of improving scalability. Then message filtering. Message filtering, there is a subject-based filtering, time-based filtering. So right now in the PubSub model, in the MQTT, we will use the topic-based filtering. There is also content-based filtering. Languages are also there. Some basic terminology behind MQTT: publish, subscribe, decouple. To now, how to send the data to the broker. So to publish or receive message, publisher and subscriber only need to know the host name and the port number. We require only two things. If you want to send data to broker, you require the host name and the port number of the broker. So for MQTT, the port number is 1883. And MQTT uses the topic of the messages to determine which message goes to which client. And every message contains a topic. Topic is the part of the message that the broker can use to determine whether a subscriber client gets the message or not. So what is MQTT client? MQTT client is any device from microcontroller to full-fledged server that run MQTT library and connect to an MQTT broker over the network. And the both publisher and subscriber are the MQTT client. Publisher is not always publisher, and subscriber is not only subscriber. Publisher and subscriber labels refer to whether the client is currently publishing messages or subscribing to messages. Basically, any device that speaks MQTT over MQTT over a TCP/IP stack, that can be called MQTT client. So publisher and subscriber both are MQTT client. Similarly, the broker is the heart of any publish subscribe model. Broker is responsible for receiving all the messages, filtering the messages, determining who is subscribed to each message, and sending to the message to subscribe client. Broker can handle outside of core country connected MQTT clients also. So now we have to understand how the communication is started. Communication started by connect and connect. First, MQTT client will send connect message, and these are the flags of the connect message: client ID, clean session, username, password, last will topic, last will QRT or services, last will message, last will retain and keep alive. Similarly, the broker will send connect message. So this is with the return code, and this is the session project. Similarly, there is a publish message. There, when you will publish message, it will send the publish message to the broker. So these are the packet ID at which topic you are sending, quality of service. So now we will use the graphical representation, we will use the flow-based programming in this. So now everyone, there is a tool that can become MQTT client. That tool is called a Node-RED. So everyone, please open the Node-RED website. What is Node-RED? So I will share the link. Just give me one. So everyone, just open the Node-RED website. This is the Node-RED. So this is, we can make it MQTT client. If you don't have hardware, no issue. We can make it as a MQTT client. So this is MQTT client. We can make it Node-RED. So everyone, please open this website. So have you opened? Everyone. So what is Node-RED now? So it is a low-code programming for event-driven application. What is Node-RED? Node-RED is a programming tool for wiring together the hardware devices. We can wire together our hardware devices, APIs, and online services in new and interesting ways. So it provides a browser-based editor. It is a browser-based editor that makes it easy to wire together flow using the wide range of the nodes in the palette that can be deployed to its runtime in a single click. So Node-RED for the it is a browser-based editor like Tinkercad. You can make it as an MQTT client like MQTT publisher or subscriber. And here we will create a flow. And we have how to make the flow. We have Node. That's why it's called Node-RED. So what are the features of this Node-RED? It is a browser-based flow editing. So Node-RED provides a browser-based flow editor that makes it easy to wire together flow using the wide range of the nodes in the palette. So there is a node palette where you will get the different nodes with the help when you connect the node, like in processing order, then you can get a flow. So you can deploy this flow by a single click. The flow can be deployed to the runtime in a single click. So what are the nodes? Behind every node, there is JavaScript function can be created within the editor using a rich text editor. And there is also built-in library allow you to save useful function, template, and flow for reuse. So it is first one. It is a browser-based editor. Second thing, it is there is a node, and every node there is a JavaScript function. You can connect the node in the processing order, then you will get a flow. Now you can deploy this flow on a runtime with a single click. Another feature of the Node-RED, it is built on Node.js. So that there is a lightweight runtime is built on Node.js, taking full advantage of its event-driven and non-blocking model. So this makes it ideal for run at the edge of the network. You can also run at the edge of the network, and you can run the Node-RED on low-cost hardware such as Raspberry Pi as well as the cloud. So it is very lightweight runtime. You will get because it's built on Node.js. You can run it on Raspberry Pi. You can run Node-RED onto the cloud itself also. Okay. So it is also for the social development. So the flow created in the Node-RED are stored using JSON. So the flow are created that you created the flow that stored in JSON file, which you can easily import and export for sharing with others. So the online flow library allows to share your best flow with the world. This is also. And Node-RED is built on Node.js. So these are the, you can run the Node-RED on your laptop. You can run locally. You can run on a device. You can run in the cloud. So you can run Node-RED onto your laptop. You can run Node-RED on Docker. You can run on Raspberry Pi, Beagle phone. You can interact with Arduino, Android, IBM Cloud, and these are the cloud on which you can run the Node-RED. It is clear to everyone. So we will install this Node-RED in our laptop. It is clear to everyone? Yes or no? Is there any doubt? Who is using the Node-RED? These are the companies that are using the Node-RED right now. So is there any confusion? Is there any confusion in this? Everyone? Okay. So now everyone see here Just click on the about. Just click on the about. So see here, Node-RED is a flow-based programming tool originally developed by IBM Emerging Technology Service Team, and now it is a part of OpenGS Foundation. It is originally developed by IBM Emerging Technology Service. So in this, there is a flow-based programming, no text-based programming. So it is invented by the flow-based programming is invented by Jaipur in 1970. Flow-based programming is a way of describing an application behavior as a network of black boxes or nodes, as they call in Node-RED. Each node has a well-defined purpose. It is given some data, it does something with the data, and then passes the data on. The network is responsible for the flow of the data between the nodes. So you can break down your problem into small pieces. So in this model, it is a model that lends itself very well to a visual representation. That is the main part. Visual based programming or flow based programming, and make it more accessible to a wider range of users. If someone can break down a problem into discrete steps, then they can look at a flow and get a sense what it is doing. If there is a problem, if you are break down into different pieces, then you can look at a flow to get a sense of what it is doing without having to understand the individual line of the code within each code. So you can actually draw the code, drawing of the code. So there is a runtime editor. Node-RED consists of node-based runtime that you point a web browser as access the flow editor. So within the browser, you create an application by dragging nodes from your node parent into a workspace and start to wire them together. So with a single click, the application is deployed back to runtime where it is run. So the palette of the nodes can be easily extended by installing new nodes created by the community, and the flow you create can be easily shared as a JSON file. This is very important part. And this is some history. It is developed by in 2013 by Nico Leary and Dave Conway Jones in IBM Emerging Technology Service Group. And what began is a proof of concept visualizing and manipulating mapping between MQTT topics. This is for the this is the proof of the concept for visualizing and manipulating mapping MQTT topics quickly become a much more general tool that could be easily extended in any direction. So in the MQTT, there are the topics. See here, everyone. So there are some topics. So what are the topics that we use here in this? The gold, the silver. These are the topic. You can say the subject of the message. So in MQTT, the word topic refers to an UTF-8 string. The broker uses to filter messages for each connected client. So the topic consists of one or more topic labels. See here. These are the topic level: my home, ground floor, living room, temperature. This is the topic level, and each topic level is separated by a forward slash. This is the topic level separator, and these are the topic levels. So in comparison to a message queue, MQTT topics are very lightweight because it is like a string. The client does not need to create the desired topic before they publish or subscribe to it. The broker accepts each valid topic without any prior initialization. So here is some example of topics like my home / ground floor / living room / temperature. This is some example of the topics like USA / so there are 4 topics level. There is also 4 topics level. This is also 2 topics are there. There are 5 topics level. These are the subtopics, and all the topics should be case sensitive. For example, like my home temperature and in capital my home temperature. These are 2 different topics. So each topic topics are case sensitive. So now we will talk about the build card. What is build card in the topic? So when a client subscribes to a topic, it can subscribe to an exact topic of published message, or it can use build card to subscribe to multiple topics simultaneously. So when you want to subscribe multiple topics, like see here, it is subscribed to like gold and silver, multiple topics at the same time. So that time you can use the wild card. So the wild card can only be used to subscribe to topics, not to publish a message, only for the subscription. So there are two different types of wild card. Single level wild card, that is called plus symbol, denoted by plus symbol, and the multi-level is denoted by hash symbol. So as the name suggests, a single level wild card replaces only one topic level. So the plus symbol represents a single level wild card in a topic. This single level wild card, only one level. So like see here, what is the example? It means before this single level wild card, there should be my home ground floor, and after this should be temperature. So at the place of plus, you can write any word like my home ground floor. At the place of plus, you are writing living room, and after plus there is temperature. So this is valid topic. Like my home ground floor. At the place of plus, you written kitchen. Then after that there is temperature. This is valid topic. These are the single level wild card. Now again, my home ground floor, at the place of plus you written kitchen. Okay. Now you are writing after kitchen brightness. So I told you already, after this single level wild card there should be temperature. But you write here the brightness. So it is not valid. Similarly, my home, at the place before the plus there should be ground floor, but you written first floor. This is before the single level wild card, after the wild card, that is fixed. You can change only the place of wild card. So this is also my home ground floor kitchen. Now you change fridge temperature. So after kitchen there should be temperature, because after plus there should be temperature. So this is a single level wild card. Again, the next is the hash symbol, that is multi-level wild card. The hash symbol represents the multi-level wild card in the topic. For the broker to determine which topic match, the multi-level wild card must be placed as a last character in the topic and preceded by a forward slash. The last only at the end. Now after this, it should be started from my home ground floor, and after that you can write anything. So like my home ground floor. After that, you can write living room temperature, my home ground floor, kitchen temperature, my home ground floor. It should be started from my home / ground floor. Like right now, you written here first floor, that is wrong. So these are the topics. So this type of concept. So that's why they are saying as a beginner proof of the concept for visualizing, manipulating mappings between MQTT topics quickly become a much more general tool that could be easily extended in any direction. So it is an open source in September 2013. You can read this story. This is the now how to install. So we have to install, or so these are the getting started. So here we can install on laptop or Raspberry Pi and these are on sensor. So please everyone click on this, run locally. We have to install Node-RED on our system. So please open this page, everyone. We will install it, Node-RED. So imagine if you are on Raspberry Pi or a Debian-based system, like on Ubuntu, on Debian or Raspberry Pi, or including Ubuntu and Diet Pi also, you can use. This is a script of installation. Similarly, this is a script for RPM-based operating system like Fedora, Red Hat, and the CentOS. Then you can use RPM install script available. And if you are using Windows, so this is the script for the Windows operating system. So according to your operating system, so first we need to install the supported Node.js version. So how to get the Node.js? So this is the web page. So here you can get. This is the. So please install Node.js on your laptop. You have to install Node.js. everyone. So this one, 16.14.0. Please, everyone, if you have Windows operating system, then click over there and install it. I have already, please, you have to download the setup file, then install it. Please, everyone, do it. And if you have any confusion, please ask. First you have to install Node.js. So there are 3 steps for Node-RED. The first one is we have to install Node.js, and the second, then we install Node-RED. Third one, then we run the Node-RED. Then we run the Node-RED. These are the, so right now we are at the first installation of Node.js because we have to install the Node.js. Please, everyone, install this. Please, everyone, install it. The Node.js. So have you installed the Node.js? You have to download the supported Node.js version here and just click over there. See here, you will get a .exe file. So this type of file you will get, and please install it. Node version 16. So please install it. This type of file you will get. Node version 16.14.0 this time. .msi file, MSI file. So please install it. So have you downloaded? Please install not current version. This is a support. This is a stable version. 16.14.0. Please install the stable version, not the latest current one. Please install the stable version. Long-term support. Okay, please install it. Please install it. So now have you installed? The chocolate is different, sir. We have to solve this one, not there. Chocolate is different. So everyone, have you installed? In my case, I already installed. So just you have to click, then it will check. So right now, in my case, I have already installed. Okay, so I can repair it, or you can similarly. Right now, I am not installing. So have you installed, everyone? So after this, see here, open the command prompt. Open the command prompt and check the Node.js is successfully installed or not. So PowerShell is open now. Write the command node -v. please write the command node space -v. So which version number is showing at your screen? What is the supported version? Node space -v. Which version number is showing of Node.js? So it is 16.14.0. Yes or no? 16.14.0. LTS is not supported. LTS means long-term support schedule is available. Version number is 16.14.0. Not LTS. LTS means long-term support available on this mode. Okay. So now the second step, installation of Node-RED. So how to install Node-RED? Sorry, for this, everywhere you have to write this command. npm install -g Node-RED. Please write this command npm space install space -g Node-RED. So npm, you have to write a small case letter npm install -g space Node-RED. The command is here, so please copy this command and please run this command. And you have to wait here. npm install space -g space node-red. And you have to wait here. You have to wait here. Now it is installing. Now it is installing. Yes or no? Installation of Node-RED is begin or not? So let it install. Please let me know if your installation is complete. Okay. So now the installation of Node-RED is also completed. Also the installation of Node.js is also completed. Yes, is in the chat. So, sir, is it sure NPM should be run outside of Node.js? It is in your normal shell. Okay, so sir, that time you can use this command, sir. So this is the command, sir. By which install the Node-RED, and this is the command, sir. npm install. This command you can use, sir. In the documentation you can read, and this is the command you can use, sir. Gopinath, sir. npm install -g unsafe from Node-RED. You can use this command, sir. Please run this. Now this is the installation of Node-RED. Now run to Node-RED. How to run the Node-RED? I will tell you. So have you installed, everyone? Gopinath, sir, now this command is working. So please install, maybe in your case the npm is not, so you can write npm install npm. Gopinath sir, please run this command, npm install npm. Please run this command first, then install the node. So now are you again getting the error? And the remaining participants have installed successfully? These steps for Windows operating system, please. Otherwise, you have to follow according to your operating system. Okay. So how to run the Node-RED? So just in the command here, write the command prompt, write the Node-RED and press enter. Run the Node-RED and press enter. So now it will show welcome to Node-RED. The Node-RED version it is showing. The Node.js version it is showing. Windows NT, this is my operating system. Now it is loading palette dashboard is also showing. So now everyone, are you getting this slide? Server is now running at. Please forget this thing. Are you getting this slide? Server now running at. Are you getting this slide? Everyone, are you getting this slide? Server now running at. Everyone. So now, if you are getting this, server is now running at. So please copy this line. Please copy this line. This one. Select this. Control C. Copy this. Server is from HTTP to till now. Just copy this. Control C. You cannot use mouse here. So just copy this line and open the browser new tab and paste it here. And then press enter. Then press enter. So this is the Node-RED. It is getting. This is the Node-RED. You are getting this type of flow. You are getting. So, ma'am, you will, Satoshi, ma'am, you will get. Don't worry. Are you getting this types of lines? Node-RED version, Node.js version, Windows like this. Are you getting? So you will get. Just wait. It depends on the internet speed also. Now copy this. Now copy this from HTTP. Just first you have to select. Then press Control C. Here you cannot use mouse. Just select it and press Control plus C. Then open the browser here at the place of URL, paste that link and then press enter. So now everyone is getting. This is the Node-RED. Everyone, are you getting? Yes or no? Please tell me quickly. We have only 10 minutes. Are you getting this? Everyone? Please reply quickly. Santoshi ma'am and Gopinath sir. Arpana ma'am. Are you getting or not? Yes, ma'am. You have to note here, ma'am. Santoshi ma'am, you have to copy on URL. Just like open the new tab in your browser and copy at the place of URL like this. At the place where you write the URL. Copy it there. And now press enter. Now are you getting this type of, like on my screen, are you getting this type of, there is a node palette, there is a workspace, this is the output page. Are you getting? Okay, ma'am, again copy it and ma'am, again copy it and run it again. Again, open this. Server is now running it. Just copy this. Press Ctrl C and paste it here. Paste at the place of URL, like see here, and then press enter. So see here, you will get like this. Like this, you will get. Anyone, are you getting this type of page? The Node-RED, have you successfully run the Node-RED? Anyone? Arpana ma'am, have you successfully get this Node-RED? Everyone? So ma'am, run the Node-RED again. Close the old command prompt, then open fresh command prompt and run the Node-RED again. Just close the old command prompt and run it again. See here, right now I am also closing. And close all the commands. Just close all the command prompt. Now open the command prompt, new fresh command prompt, CMD. This is the fresh one and write node -red and press enter. And then press enter. Now here you will get server is now running it. Just copy this. And open this and Control V and close all the remaining. If you on another tab, if you are running Node-RED, please close all the and just click on new tab, then press enter. The Node-RED must be run on single URL. Just try to install it again, ma'am. The installation is not correctly done. Please install Node.js, then install Node-RED again, then try to run this command, node-red. Because on any other tab, your your Node-RED is running. So just close the other tabs also. This type of error, we will get this type of error when we try to connect to the same host, while you are stating that your server is running on a different host. So this is showing it. So this is the Node-RED. So see here, everyone. In the Node-RED, this is the inject node. This is the debug node. We can connect the node like this, and we can change our right now the payload. Right now, I am sending the hello world like this. Then click on done. And when we deploy it, so at the output, in the output, you will get the message. See here, this is the hello world. Every time I press, you will get the hello world. So this is the flow. This is the nodes. These are the nodes from the palette. So see here. So these are the node palettes you will get from the left hand side. The middle one is your workspace, and the right one there is a output pane. So you can connect the nodes. You can run the nodes. See here, these are the some nodes are already there. You will get there are some nodes in different categories. So this is the first part of hands-on. Then installation of Node-RED is completed. So if you have any doubt, you can ask verbally. So this is and from my side the installation of the Node-RED. So at 12:30, we will start again the next part. So Aditi ma'am, are there? Everyone, is there any doubt you can ask? Aditi ma'am, are you there? Now we can conclude this session. Hello.
Yeah. So dear participants, if you have any queries, please post in the chat or Q&A section. Or you can also raise your hands so that we can unmute you and you can ask your question.
So yes, so this is the drag and drop. Just this is the inject node, and when you click on inject node, you can read about this. What is inject node? Inject a message into a flow. When you click over there, this is the debug node. Right now, what they are showing, so the blue dot are saying their changes are unsaved. So just connect this like this, and this is the timestamp. Right now, it is showing. You can change the data, the payload from here. Like there is multiple options. So you can write here like hello world. You can write here. Then click on done. Now you connected. Now you have to press this deploy button to run the deploy. So you will get deploy here the debug. So when you press this, you will get hello world. Okay. Is there any other doubt you can ask? So this Node-RED becomes the MQTT client, publisher or subscriber. Yes, is there any other doubt? You have to double click over there. Ma'am, you have to double click on the node. Yes, is there any other doubt? So this tool we will use in our hands-on. So just double click on the node. Here you will click over there, change the string number, right? right now, if you written here the number, set the number, now write the number 1, then deploy it, then click on confirm deploy. So see here, this is the debug message you will get. Now you have to press this button. And similarly, this button you have to press on the inject node. This button you have to press. Is it clear now? Okay.
So all the query parts have been answered. So Jitesh sir, we will wait for another 1 minute.
So you will get linking by right click. See here, by the right click you will get the wire. By the right click. Yes, ma'am. Hello. Did you, ma'am?
Yes, sir. Yes, sir. You can.
So this is end from my side. Your voice is breaking, ma'am.
Hello, is it audible now?
Now I'm audible.
Okay, so I guess if the query
So the same tool we will use after 12. So remaining doubt we will resolve on 12.
Okay, sure. So dear participants, the same tool will be used from 12:30 onwards also. So if your queries answer, so we solve. To join.
And your voice is breaking. Hello. Your voice is breaking. I'm not getting it yet.
Hello. Hello. Am I audible?
Yes, sir.
Yeah, so I am saying that we will continue with this tool from 12:30 onwards also. So in case if any of the participants' query are not answered, we will answer it after 12:30. Is that okay, sir?
Yes, yes.
Yeah. So thank you, Jitesh sir. Thank you for joining and making this session 1 of day 10 of the program successful. Thank you, sir. Thank you for joining. So, dear participants, the attendance of day 9 has been already updated. Also, we have posted the feedback link of the program in the drive. So, we request all the participants to please give their valuable feedback before the program ends. So, next session is session 2, which we will begin at 12:30 onwards. So, we request all the participants to remain connected. We will resume after 12:30. Thank you all. Hello.
Hello, ma'am.
Yeah, good afternoon, sir. So we have made you the presenter in the meeting. So we request you to please share your presentation.
Okay, ma'am. Okay. So, ma'am, I shared my screen. So,
Yeah, it's totally visible.
okay.
So it's already 12:31. So shall we start now?
Yes, ma'am. For my side, we can start.
Yeah. So good afternoon, all the participants. So I welcome you in this second session, second and last session, in fact, of this online faculty development program on IoT and application smart systems. So this will be the hands-on session 9, which will be continued from here onwards. So Mr. Rishabh Kumar from IoT Academy will be taking this session. So over to you, sir.
Okay. Thank you, ma'am.
Thank you.
So, it's a continuation of the earlier session. So, today's session is a hands-on on energy monitoring solutions. So, in this, we will be sending a smart energy meter reading to a Node-RED dashboard and by using our Node MCU development board. So I think all of you have already downloaded the Node-RED and a Node.js, which is done by Jitesh Shah in the earlier session. Okay. So how many of you have installed the Node-RED? If please, you can just write in a chat or a Q&A. So I will start from the installation of a MQTT broker. As Jitesh told me, he ran out of time and not able to install the broker. So I will show you how to install a MQTT broker. So any participant can confirm that they have installed the Node-RED and it is working fine. So today we will be using EMQX. It's a MQTT broker, means it's a MQTT server and it's an open source one. So we can also use Mosquito, which is from Eclipse, but the original, the problem with the newer version of the Eclipse is that it's a local system. So we cannot use it over the IP. For using over the IP, we have to like manually put the IP of the sender and the receiver. But from the EMQX, it's a more flexible and very good platform. So you have to search for EMQX and then you have to go on this website. I'm posting this link in the chat box. This is the link I'm sharing. And from here, we can just simply go from download. Here you can see there is a download button and we have to just click on the download and then we have to choose our OS. So I'm using Windows. So I can choose for Windows. If you are using Ubuntu, then you can choose for Ubuntu. And Debian, you can choose for Debian also. And for Mac OS, it is also there. So I'm using Windows. You have to select the OS as per your operating system of your PC. And then you will click on the download. So it will be downloaded in a zip file. So here you will get a zip file and then you have to decompress that zip file and you have to go in the terminal or in a command prompt in Windows and then you have to just navigate to the bin folder and then you have to start the EMQX. And after starting that, it will ask you, there will be pop-up, and it will ask you for a firewall permission for the first time, for the Windows firewall or the Mac firewall. And then once you allow it, it will be start working. So any of the participant can confirm me that they are able to get the link and they are able to follow this process. Please confirm in the chat or the Q&A session. You can. Okay. So I just sent the link in the chat. You just need to go on that link, and you have to click on the downloads buttons. And once you click on the download button, here you see it says get started, and here is the OS selection. So we have to select it for Windows. Because I am having a window, you can select as per your OS. Like if you are using Ubuntu, you can select Ubuntu. If you are using Windows, you can select Windows. If you are using Mac OS, you can select Mac. So I'm using Windows, so I'm selecting Window and clicking download now. And after that, you can see here is the file. You have to click here to download it. Let's say if I click here, and it automatically downloads a file. And this is a 30 MB file. It's downloaded here. And then you have to extract it. If I open it, sometime. So here you can see the folder. Let me copy this. And I have extracted here. And once I extracted, we just need to navigate to its bin folder and simply write EMQ start. There is a command given there. Here is the command, sorry. This is the command given. So I already have downloaded in my C drive. So let me go in the C drive, I think. So is my command line visible to you? Okay. So I have to go in the folder of EMQX. So here I installed, have extracted it already. Then I have to go in the bin folder. I have to go in the, because I extracted in the EMQX, I have to go in the EMQX. Then I have to go in the bin folder. In bin, if I do, here you see we have to run this file. So I have to click write a command emqx start. So if you see, this is the folder structure. Here is the first folder, and here is the extracted data. And from here, I have to go in the binary section. From binary, I have to run this file, emqx start. So I have to emqx start. Now it's start. And if I have to stop it, let me. Yeah, if I have to stop it, I can simply write emqs stop. And it will reply with the OK, and it will stop. For starting, we have to send this command, write this command emq start. So let me start it again. I just started it. Now it's started. So how to check it started? We have to go in our browser and type localhost. The port is 18083. And here you can see it asks for the username and password. I'm copying this and pasting it in the chat. And the username is admin and password is public. It's the default password. And once you start, you will see this dashboard. Once you start, you will see this dashboard. It shows you how many connections are there, how many topics are there, and this is a very kind of a feature-rich MQTT broker from where you can manage all your clients and all the network. You can manage it from here also. So even this broker we use for our own purposes, like for our industrial deployment, we use this broker. We deployed it on the AWS compute, and from there we are using it. So for this, you only need a public IP, and it will be accessed to public also. But here, because I installed on the local network, so it will be accessed from my local network only. So am I clear till now, or do you have any questions? You can ask simply here in the chat box or on the Q&A section, and I will take the questions also. So how many of you are able to download this or install this broker? Can anyone confirm? Because it's a simple process. You only need to extract it and go in the command. Username is admin and password is public. Sometimes what happens when you run it for first time, it will give you a pop-up in a firewall. You will get a firewall pop-up, and it will show do you want to allow this service, because this service utilizes 188.1.8.0.83. These two ports it wants to access from the network. So that's why your Windows Defender or any other antivirus will block it. So if you have any antivirus, you have to stop the antivirus, then you have to start this system, then you will whitelist in the, then you will allow it in the firewall, then you can start your antivirus. So sometimes the antivirus programs pick it as a virus or a malware, so and they keep it blocking. So I think some of the participants have downloaded this EMQX. So is there any question, or shall I move forward towards hands-on? So here is the simple agenda, and this is the overview. We will be using the same Node IoT, Node MCU IoT board, and it will request current, voltage, frequency, power factor reading from a Modbus based energy meter. So today we are using a Modbus based energy meter, which is used mostly in the industrial purposes. For our home utilities, there will be a different protocol. Sometimes it is Modbus, but sometimes it is a different protocol which our utility meters are read. Like most of the time, it is HDLS, HDLC, or it's a DLMS. So meter reading will be published on a topic, because all of from previous session you know that we need a topic for subscribing and publishing. So we are using out topic as a topic, and then what happened, our Node MCU board will act as a client, and our Node-RED will act also as a client. So we will be using two clients, and the EMQX broker will act as a server. So after these two clients will connect to a server, this EMQX which act as a server, and the Node MCU development board will publish the data. It will be publisher, and Node-RED will be subscriber of the data. And we are using JSON for our cloud connectivity part. On our meter side, we are using Modbus protocol for sending data from our Node MCU to our meter via RS485. I will explain about RS485 later, and also what is Modbus later in the PPT. And from here, we can also receive it on any other platform. If I put it on the public IP, you will be able to receive that message also. So these are the type of energy meters we are familiar with. So mainly they have some of are for the residential, business, and electricity purposes. So here are some of the types. This one is more of a DIN rail mounted system, which is mounted mainly used in industrial space, where we mount it on the DIN rail, and we have to monitor the power factor, and any other meter reading like a current, volts, active power, reactive power, total power, power factor, and any other parameter we want to read. Like it has a lot of parameters it stores. And then we have our normal home meter, which still have these much much data, but only it is used for billing purposes, not for the diagnostics and other purposes. But these two meters, like one here, it is a DIN rail mounted, which sits inside an enclosure that we are using currently today. And here is a panel mounted enclosure, which is mounted on a panel from on any of the instrumentation panels. It is mounted, and from there we can see the reading also, and we can take data also by using the Modbus or the Ethernet based architectures. And from the utility meters, the electrician has a particular instrument which he brings a meter reading device. He connects the meter and takes the data. Nowadays, smart meters are also available, smart utility meters which send data to GSM, and then it is automatically billed. So again, moving to advantages of IoT based energy monitoring systems. So okay, so real-time energy monitoring we can do from here, and it is not only like not it is not for the meter reading purposes only, like for the billing purposes, but for the utility meter reading or general meter reading is a very much helpful, like in understanding the power demand, because what the problem always is, like we are consuming on an instantaneous level, but the power plant has to forecast like what will be the energy demand. So according to that, they can generate electricity. When there is a less demand, they have to because they cannot store the energy, so energy cannot be stored. So if these calculations go off, then there will be a huge blackout because whole grid infrastructure will be shut down. So that's why they want a complete budgeting, like what is the requirement for this time, you know. And for industry, they have a certain limits, like from they have certain, they divided a time in a particular period, and they give you the budget that from this duration to this duration you can only consume this much of a kilowatt, from this to this you can consume this much of a kilowatt. And if you violate these rules, then you will be get fined from the utility company. So that's why the industries also monitor their energy consumption. And also this energy monitoring helps you, like it's mm, like you're maintaining the health of your machine. So it can give you maintenance data and predictive data, because these current and voltage parameters are often related to your health of your machine also in some cases. And also it makes the process like more automation, like individuals can track their energy consumption and uh, power, and we also cut down the power consumption. Like if we know that we are using this much electricity, so we can save it like by using by conserving the electricity and using it on a right amount. And also we don't need manual labor, like no we don't have to send an individual to every household to collect the data. And here why we need energy monitoring, because already these come from our non-renewable sources, made most of our energy, so it increases the CO2 emission. So that's why we want to reduce the CO2, and we want to be more efficient. If we can if we track something, then only we can optimize it. So the best, so first thing is to optimize anything is to measure. So if we precisely measure our power consumptions, then we can only optimize it. Like for the industries, they have several machineries and the instrument, uh, like they have lot of them, and they have hundreds of machineries. Sometimes they have thousands of machineries deployed. And on what they do, they monitor on each level, like for every machine what consumption is there and what is the total consumption, so they don't waste the power. And there is a term you can you have maybe come up with, or you know, like power factor correction devices. Because what happens, because these industries drive a lot of inductive loads, and which lowers the power factor, and which drastically increases the bills, energy bill, because a lot of energy is wasted also. So by tracking our power factor, we can minimize the losses. This is a simple flow diagram of a current setup. Here I'm using the same Node MCU IoT development board, and here I'm using a small RS452 TTL converter. So from here I'm using UART as a serial communication, and here I'm using RS485. So RS485 is a physical uh, protocol. It's and on the top of that, the application protocol which is running is Modbus. So RS485 is just a physical connection protocol. Like it's a physical logic level. It's a more like a RS232, but it only utilizes 2 wires, and also it has a long range. Like from RS485, we can easily communicate up to a kilometer. If we have a good receivers and a good shielded pair of wire, so we can easily communicate up to 1 kilometers of wire. Whereas from our UART normal TTL logic, we can hardly communicate from like a meter or so. So let me show you my current setup. I think my setup is visible to you. Let me stop sharing. So here is the same board as you are keep on seeing this. I'm using in every experiment. And here I have a RS485 to TTL converter. It's a simple RS485 converter. It uses a Max 485 IC, which I guess you are familiar with. And here is our energy meter. So currently I'm not using any power. So here you see it showing the voltage, and now it's showing current because I'm not consuming any current. It is 0, and then it power factor because nothing is connected. The power factor is 1. And for load, I'm using a small exhaust fan. Here I'm using exhaust fan. So this is the setup. And this is the wire which is connected. It's a Modbus communication protocol. I'm communicating with meter via this 2-pair twisted wire. That is RS485 physical layer, and on the top of that we are running a Modbus RTU protocol. So anyone have any questions till now? Please, if you have any question regarding this, ask in the chat section. So this is my current setup, and this is the setup for the industrial energy monitoring. Present time, what is it? So like smart meter, we are also working on like DLMS based DLMS based smart meters, where we are using LoRaWAN to send data to particular gateway. So it utilizes very much low quotient current as compared to our traditional SIM based devices. So it reduces overall less. So LoRaWAN, DLMS and LoRaWAN are the two things that are widely used in smart meters these days. So here you can see this is a industrial energy monitoring solution setup. So we here at IoT Academy, or Uniconverge, which is a parent company of IoT Academy, we are the OEM manufacturer of the gateways. So we design gateways and we provide a complete energy monitoring solution to industries. So from here you can see there are various meters. They all are connected via a single bus, which is RS485, because RS485 can support peer-to-peer networking as well as multi-drop architecture. So here they all are communicating via single bus. So the beauty of RS485 is like we can have a lot of devices. Theoretically, you can have 245, 246 devices, but in practical, we can have up to 32 nodes on a single RS485 drive, RS485 physical layer. And after that, if you want to add, you have to just add a repeater or something, device, other device which act as a repeater, because as much as devices we keep on adding, the overall line get more complex, and also it decreases its because each have its own termination register. So after adding 32, 33 devices, the losses in the line due to impedance mismatch is huge. So we cannot able to add a lot more devices. But in theory, it can support 245 devices, up to 255 devices it can support, because Modbus has an 8-bit addressing. But on RS485, it's mostly 32, 33 devices we can support, like on a realistic figure. So they all are connected to a single device, and then this device is acting as a Modbus master. They all are Modbus slave devices from where we can read the data, and then we can send the data via MQTT with the help of Ethernet, and we can send it to MQTT to mobiles, laptop or desktop or any other application we want. So here is the industrial energy monitoring setup. And here is a DLMS which I'm talking about. So DLMS is the DLMS slash COSIM is a industrial standard for utility meter reading. It's not just for the electrical meter standard, it is for the gas meters also, it is for the water meters also. So DLMS is a open system interconnection. So what it does, it gives you a standard. It is more it treats a parameter as an object and gives gives a reading, kind of like it is designed for meter reading. So any metering application will use the DLMS standards. So nowadays all the meters from the utility providers like our UPPCL or any other company, they have this DLMS based meters, and the most of the major companies manufacture these DLMS based meter for for consumer application. You can learn more about the DLMS. You can just search on the Google and you will see that where DLMS is used. And here is a simple example that we have done so far. So we, for a for a utility company, we done a project where we use their meter, which is of LNT meter. And for LNT meter, we designed a LoRa node which can read the data and send it to a central gateway. So the problem statement was there, like the utility meters are very far away in the remote location, like in a village where a farmer have this in their farm. And what happens, like they farm are very parts, some are 5 kilometers away, some are 2 kilometers away, and for reading the single meter, one person has to go there to generate the bill. And the problem is, like, they don't have a very good cell coverage, so they cannot utilize this for 2G or NB-IoT based prepaid energy meter or smart meters. So they wanted a LoRa because LoRa have a very great range, like it consumes less power and we can get up to 4 kilometers, 5 kilometers. And if the LOS is good and everything is in the favor, we can easily get up to 10 kilometers of a range. So practically 5 kilometers is easily achievable. Then all the data is sent to cloud. So it saves the huge cost for the utility also. So we designed a complete POC and a product for them, and it uses a DLMS meter reading. So it is connected to meter via the RS-485, but as today we are using Modbus, but it is using DLMS. So DLMS is a different protocol than Modbus. And here is the dashboard. You can see it has a gateway ID. And it has the meter serial number. It's the meter serial number. Here you can see the frequency. Power factor is 0 because we are not reading it because current is also 0 and it's a 3-phase meter. And instant load is 0. And for the first phase, it's 213 volt. Second phase and third phase are not connected in our case. So here you can see we designed a complete dashboard. So what this dashboard does is, like, it acts as a sensor in every household. So they can predict what will be the load requirement of a particular user, what will be the power consumption, and also, like, if we can meter on a runtime, then we can also reduce the theft of the energy. It's if we have a node to node measurement, like if we have a measurement from a distributed transformer, the DT, distributed transformer, and to the end node, then we can sum it out. Like if we have 10 consumers and we have one distribution transformer, and then then the ideal condition is the sum of all these 10 consumers should be equal to the reading of this particular DT node or this distribution transformer energy consumption. But if it is not matching, or is there any very large discrepancy in the readings, then we can easily identify that there is some kind of a problem or is there some kind of theft happening. So these things can be easily addressed with the help of energy monitoring. So here is the simple setup that we made. Like here is the wireless GSM gateway. We have the Ethernet gateways also, and here is the LNT 300 series or something. I'm not sure. This is the meter we used, and here is our LoRa node thing. It just read data via this RS-485 wire, and then sends data to cloud. Using this wireless GSM gateways, it sends. And if we have a Ethernet, we can send it via Ethernet also. So any questions, participant, regarding this setup or anything? Please, if you want to ask any question, you can ask in a Q&A or chat, or even you can raise hand. So let me show you the demo video. I have a demo video also. So here is a demo video that we done like 2 years ago. So here is a ERP, sorry, 300, yes, ER 300. And here is our node. And here is our gateway, which is sending via GSM. And here is our dashboard. So you can see all the parameters are coming. I can play this video one more time. Like here is our load, that it's a small electric bulb, and here is our utility meter from L&T. It's a standard ER3 300P. It's a 3-phase meter which is given to us by the government, and we are using this RS-485 cable. They have both the interface, like RS-232, RS-485. They have all the interfaces, and it also have the optical reading. If you want to read it from optical, we can read from this one. And from here, there is our DLMS meter data reader node, which is using LoRaWAN to send data. And from here, I'm sending data to this node, which again have a LoRa and a GSM node, sorry, GSM modem in this case. And it is sending data to our cloud platform. And you can see for the POC, I'm still using Node-RED. That time we also used Node-RED for prototyping this, and we are sending data to our server and visualizing via the Node-RED. So any questions or any problem you are facing, or if you are not able to catch, you can simply ask. I can explain again. So moving forward, then, because I'm talking more about Modbus, so what is Modbus in this case? So Modbus is a communication protocol. It is designed for communicating multiple devices. It is designed by Modicon, and now it is owned by Schneider Group. So earlier it was designed by Modicon, and then Modicon was acquired by Schneider, and they have, because they launched their PLCs as a Modicon PLC lineup. So Modbus was a native feature of the PLCs. So the first it came in the PLCs. Like they have to have a multiple IOs, but these IOs are distributed in the field. Like they can have hundreds of IOs or thousands of IOs, but all that cannot come to a single place. So that's why Modbus is developed to have it's a field bus. It's a field bus protocol, I can say, because it interface the field devices to a central device, and 247 slaves can connect, and they all have a unique ID. So Modbus is two types. First is which run on the serial wire, which utilizes serial wire, and that is called Modbus RTU. The another one is Modbus TCP IP, and it utilizes the standard backbone of a Ethernet. So it starts as a Ethernet packet. So and so it can be easily done by our network infrastructures. But back then, when the Modbus was invented, there was no network infrastructure as such in the industries. So because it's very old protocol, like it's a more than 20-year-old protocol, 20 or more than, even more than 20 years. I think it's kind of 30 years now. It's a very old protocol. So here is the Modbus frame structure. It has an address. In this case, it's have an address, and it has a function code that it has a 1 to 16 function code from 1 to for reading and writing, reading single data, reading multiple data, writing multiple data, and writing single data. So that combination has 16 function code we have here, and they have a coil and registers. They have holding registers, they have input registers. So these are the function code defines that. And then there will be the data, that what is the amount of data we want to write or what amount of data we want to read. And then there is the CRC. In the Modbus RTU, we have slave ID, the ID of the slave, the function code, then the data. And in the Modbus TCP, this same architecture is utilized, but only the slave ID is replaced by the AMBAP, which is again transaction ID, protocol ID, then the length of the data and the unit ID. And here is the simple architecture. And this is the point-to-point communication of multiple PLCs with each other using RS-485 Modbus architecture. And here is the simple example where one is the master PLC, another one, they all are the slave links. So they all are connected in the multi-drop manner. And here again, example of these sensors, various sensors and slaves. So there is one master in the system, and then there is all are connected via RS-485. Sometimes they can be connected via RS-422 also. RS-422 is the full duplex protocol. RS-485 is half duplex. RS-422 is full duplex. So, but most of the time, because Modbus is already a half duplex communication, like at a time master can request, then only slave will send the response. So most of the time RS-485 is used, because it also saves the wiring, because for RS-422 we need 4 wires, for RS-485 we only need 2 wires, single a pair of wire, like only 2 pairs. Here is slave 1, slave 2, slave 3. They all connected via a single bus. And here is the overall architecture. Let's say if we want to deploy in a big industry and we cannot run a lot of wires, so we have to deploy in this particular arrangement where we on the very root node level or very edge level, we can have our Modbus RS-232 mod, or if we have multiple levels, we can have Modbus RS-485, and then we can have a central networking where we can access it via Ethernet TCP IP, and then it can connect to a central DCS or a central PLC, and then it can go to a SCADA system or a cloud. In our case, it can go in the cloud. Okay, so let me move forward. Then here is the same. What is the use of Modbus? It's an open protocol that all people can use. So all the major manufacturer uses it as their primary communication protocol, and it is very used for sending a low data rate. The only downside for the Modbus is like it is master and slave driven protocol. So it's not a client server model. So always the master has to ask for some data, then only the sensor can send. The sensor cannot send you the alert. It is not going to happen in Modbus. So that is the main drawback, but still it is in the industry, it is widely preferred as master is always keep on continuously polling each of the devices. So for controlling instrument, it is more preferred to have a central control. So it is what is slave, because we will slave ID is just ID which is given to each client, sorry, each slave. Like in our case, our meter is slave. We have sent the slave ID 1 for this. So if we have multiple devices, we can send a different slave ID. And the first byte of the message is a slave ID. So the slave ID when a master sends a message, only the which have a matching slave ID will respond, and all the other will ignore the message. And here is again what a RS-485 is. I already explained, I guess, but let me explain you again that RS-485 is an industrial uh, electrical interface for physical point-to-point communication or multi-drop communication, and it supports multiple devices on the same bus. And it allows you long cabling distances. Why it allows a long cabling distance? Because it's a differential signaling. So even the signal get attenuated and it is get mixed with the noise, then at the receiver end, because it's a differential signal, so both the signals are deteriorated at the same level, so it can easily recover that data also. And the huge advantage of this RS-485 is like we don't need to have a common ground. So these two can be completely isolated systems and still can communicate with each other. So any doubt or questions till now? Because now I will be moving on the hands-on where I will be installing library and programming the Node MCU, and then we will be making a dashboard for visualizing the data. So I will give you 2 minutes. So please ask the questions, and then I can move forward. Okay, so now I'm moving to the hands-on part, like how to program Arduino. The Arduino code will be shared to you, but what are the prerequisites? I go with the prerequisite, and we need a ESP32 with the Arduino IDE. We already configured it uh, in the previous sessions, so we will be programming that only, and then we will be use MQTT. The MQTT is a IoT protocol, and we need a broker. So from here, we need EMQX or Mosquito. Both are preferred, but as EMQ is more robust and more, it has more features, and also it is more scalable. So we will be using EMQX today. But if you have a basic thing, then Mosquito can also be used. For your local computer, Mosquito can also be used. And we will be using libraries like PubSub is a library for MQTT. So I'm using a PubSub library for MQTT. for MQTT. It's a public subscribe client because MQTT is a publish subscribe model. And then we will be using a Modbus master library because we are making it as a Modbus master. We are not making it as a Modbus slave because slave is our energy meter. We are making it Modbus master. So we will be using a Modbus master library. So you have to go, the same process will be there. Like we have to go in the sketches, click on the include library, then we click on the manage library. Then we will get this library manager. So I have to search for pops up. And here you can see this is the PubSub client that I'm using. So we have to search for the PubSub client only. So this is the library we are using today. There are a lot of libraries that can be used, but this is what we prefer using. And it is like grown, it is there for like more than 4 and 5 years. So it is a very stable library. And the another library is Modbus Master. So this is the Modbus Master library that we will be using. Okay, you have to install this Modbus Master library also. And then we are sending data using JSON. So we have to install JSON also. So we will be using Arduino JSON. There are a lot of JSON libraries like CJSON and another libraries for C, but we will be using Arduino JSON because it is a very lightweight JSON library and it runs on the microcontrollers very easy. Like C, JSON or JSMN, they are more heavier side. They will take a lot of resources. So am I clear till now, or you have any questions? So after that, we will require the hardware. So hardware is ESP8266 node MCU. And this is a energy meter, a cell energy meter. We are using it from a Select company. So it's a energy meter, but any energy meter with RS485 Modbus you can use. And then we need a TTL to USB, sorry, TTL to RS485 module because the ESP has a TTL logic level. So it has a UART logic level, but we need to convert it to 485. So we will be using a TTL to RS485 like a simple MAX 485. If you MAX 485 is the IC that is used. So this is the module I'm using. And this is the data sheet of the Maxim 485. Here is a data sheet of the Maxim RS485 that is widely used. So here is all the specs it have. Like here you can see it uses two pair of wire, and one is a driver and another one is a receiver. I shared the link of the data sheet so you can go through the RS485 specification. And here is the simple pin configuration like RX, ESP to the TX pin, RX pin, and how they are connected. And the TTL is connected to A, B pin, A, D plus D minus we call it. And for meter, it can be different. Like for meter, for every meter it is different. So let's move to Arduino library IDE. And now I have to specify this SSID, the password, and our MQTT server. So for let's say if you are running on a local server, because I'm currently running on a local server, because my EMQX is installed on the local network, and my Wi-Fi network is this, and I'm connected to a same network. My uh, Node MCU and my computer is connected on the same network, so we can access it from here. So I have to give the IP address of my computer where the EMQX is installed or the mosquito broker is installed. So like what we can do, we just go in the command prompt. We have to get the IP of our computer. So we run ipconfig command, the command prompt, and you will get this IP of your PC. So for if you are running on a local, you have the only prerequisite is you have to be connected on the same network, on the same Wi-Fi network or the same Ethernet network, and then you can communicate. Your device and your computer can communicate with each other. So this is the IP of my, it's a 10. So I just placed here 10, and then here is the code. So we first set up the Wi-Fi. Let me go to the setup. So we just set up the like built-in LED as output for initialization. Then we start the pin mode for max 485, max 485 transceiver. Sorry. Then we use serial begin. So we are using a baud rate of 9600, and then we will give a slave ID. For here, slave ID is 1, and we are using this serial peripheral. So we pass the serial here. And they are the function for the pre-transmission. What happens like there is a flow control pin, so it toggles the flow control pin after the before the transmission and after the transmission. Then we have to set up the Wi-Fi, and then we have to set server. This is MQTT server, and this is our port number. And then we have to set the callback. If we are subscribing, then we have to set the callback, but we are not subscribing here. Then what we are doing, we are reading the input registers. So because the data is stored in the input register of this no this meter. So we will be reading the input register, and we will get the response, and then we will extract the data, then clear the buffer. Because it comes in the same buffer, then we again query for current. Similarly, we will query for the frequency, then we can query for the power factor, and then we will convert these messages to JSON, and then we will publish it on a topic, the out topic, as a JSON message. So participant, please feel free to ask the questions or the doubt. Like even if you don't have the hardware with you, it is kind of these concepts are very much useful. So if you have any doubt or any question, please ask. Okay, so we got the code. We have this code I will share with you. And now what we need to do is like we have to make a dashboard also to visualize the data. So we have to start our Node-RED because Node-RED will be used for visualization purposes. So you have to start Node-RED, and how to start a Node-RED is like go in the command prompt, and if you are able to install it as a global variable, then you can simply hit node as red and it will start. Okay, and if for some reason it is not installed in this configuration, not in a global mode, so what you need to do is like you can navigate to this particular location where the red.js file is, and you can start. So let me show you. Like I have installed in program files in the node. Is it visible? The Node-RED, Node.js, because it's a part of a Node.js, and then we go, it's in the Node modules because it is a module of a Node.js. So it will be in the Node.js, and from here we can check for the Node dash red, and it is available. And here you can see there is a red.js. And to start it, we have to send a command, write a command node, because we are using Node.js to run it, and then we have to run the red.js. And from here, it will also start, as you can see. But the best preferred way is to install it globally and run with this simple command like start Node-RED. Sorry, only Node-RED. You just type Node-RED and it will just run. So please start your Node-RED. And after that, I will be continuing the experiment. So my Node-RED is running. And after that, I have to go to localhost, and a port which uses which is utilized by Node-RED is 1880. So if you are not sure, what you can do is like you can copy this address. You can see it says server is running at HTTP this, and you can just simply copy it and paste it, and it will also work. So I have many of the flows, but I think you will have only one or two flows, one flow, because I have many of them made. So this is the flow that we will be using today. But first of all, we need to install the dashboard palette. Here are the palettes, but I think you will not able to see this dashboard palettes. So we have to install them. We can all use as much palettes as we can. There are a lot of them on our Node-RED website. So Node-RED is a very great tool for prototyping and IoT and learning purposes. Even for deployment, Node-RED is a very great tool, I can say, because I'm using it for more than 5 years, and still it is a very good tool, and it is quite matured a lot also. But from the day one, it is a good tool. So you can from various other people's, because it's open source, from other people's you can also get their flows and learn how to do things with there are a lot of tutorials are also available. And how to install a palette, I will show you. Just click here on these three dots, then go on the manage palette section, and then click on the install, then search for dashboard because we want a dashboard. So search for the dashboard, then we have to install node-red-dashboard. It can be installed from here also. It can be installed from the npm package manager also. But this is the one of the easiest thing to install, because earlier it is installed only by the npm command, node package manager command, but now we can easily install with from here. You can just simply hit install and it will install it. So we have to install this one. So any of the participants are able to start their Node-RED and are able to install this dashboard. I'm pasting the text in the chat box. Please, participants, do let me know if you are able to start the Node-RED or you are able to install the dashboard, or if you are facing any problem in installing the dashboard, please let me know. I can help you in installation of the Node-RED. But it is very simple. Like you have to just go in this three dots, then click on the Manage Palette option. In the Manage Palette, you have to go in Install, not on the nodes. You have to go on the Install, then paste the message which I sent in the chat box, the name, and you will get, and you just simply install. Like if I paste it from here, you can just see it's on the top, it come, and you have to install the first one. It is as simple as that. So after installing this, we will get this dashboard options. Like here, we get this dashboard options. These are the drag and drop elements we can get. Like you can see, if I go here, you can see I got all these gauges, charts, UI control notifications, input. So I'm using the gauge. Like here, I'm using a gauge. So for gauge, what you need to do is like simply drag and drop this, and you have to add what the label of the gauge is, and you have to add the unit, or you can add, or simply you can just whatever the like label should be, whatever the value it is showing, it will be a label. Like I'm showing you the voltage, the current, and here I'm using a MQTT. Like in the network section, you can see here is the MQTT node. So it connects with the MQTT. So if you click, you have to click on this edit button. And from here, because we are using a local host, local network, we can like put a local host here, or 127.0.0.1 also can be put there. And from there we can access this. And we don't need the client ID. It can be auto generator also if we leave blank. And here we are not using any security for now. So we just leave these blank, and then you just hit on update. And after that, it will ask for the which topic you want to subscribe, because this is a subscribe node. So if we want to our topic is out topic, which we put in our code. Like if I show you in the code, here you can see the topic is out topic. I'm publishing on the out topic. So I have to subscribe the out topic. So once I subscribe the out topic, you just hit on the deploy. And now you see deploy, it is deployed and connected. If we want to publish some message on some topic, then we have to use this node. MQTT out means publishing, MQTT in means subscribing. Because I already connected the node and it is all the data is coming in the JSON format. Here you can see voltage, current, frequency, power factors is all coming. And what I'm using is using a debug node. Debug node, what it does, it sends any of the message in the debug window. And I'm using a simple JSON parser object from here, parser JSON, and what it does is simply converting these strings to a JSON object. Already they are coming in a JSON string and it converts into a JSON object. So that's why we can easily, Node-RED can easily understand it. And here we, in a function, we just written a very small function. It parses the message dot payload of thing into object, JSON object. Then it saves the variable into a, then it saves the object into a variable like particular key object. Like key, voltage is a key. Here voltage is a key, and it is passing this value of this of voltage into this variable, and then now after that we are passing that value into the message dot payload object, because they only accept message dot payload. I will also share you this dashboard also. Like you can simply import a dashboard from here. I will share you the file. From there, you can just simply click on select an import file, and you will able to import it. But you need to download this one. This dashboard you need to download. So as you can see, the function is there. We have created similarly chart is similar function. You have to just pull the chart and you need to wire it. Like simple wiring is simple. Like just connect one node to another. Like you can simply wire it up. So it requires some practice also. And once you install the lab, this UI, what you need to do is like you have to go to localhost/UI to access the dashboard. I have a multiple dashboard, that's why it's showing you, but you will able to see this dashboard. So here you can see like the current is 0 because our motor is not running, and here is the voltage which is plotted, and here is power factor which is 1 because there is no load is running, so power factor is 1, and the frequency is 50 hertz and current is 0. Let me turn on a load. I'm turning on the fan. And now you will see it is consuming 260 of a milliamps current. And now what is happening? You see the power factor is declined. Why the power factor is declined? Because it's an inductive load. So inductive load decreases the power factor. So for maximum performance, we have to have a very good power factor, like closer to 1, but it is in real life scenario, it is not possible. But what we do is like, because it's an inductive load, we have to compensate with a passive load. So with adding a passive load, with adding a capacitive load, we can just simply correct these power factors. So here is our current reading, and you can also see here in the debug, it is coming. So from anyone in the audience can confirm that they have the Node-RED with them and they have installed a dashboard. So I can also send the data to your dashboard also via public MQTT broker. So here is the node which is running, and here is the meter, and here is our IoT development board, and this is the readings. And if I stop the motor, let's say if I stop the fan, now you will see it is the current dropped to 0 and power factor just again came back to 1. You can see. So participant, any question? This is for this is the today's hands-on where we are monitoring the energy consumption of a fan using a Modbus and Node MCU, and we are using this Node-RED as a dashboard. So anyone have their Node-RED running? Can anyone from the audience can confirm that they have their Node-RED running? Okay, sir, there's a question. How much this energy meter cost? Sir, depending on the amps and amperage, it can cost you around from for a good one like these, or if you can go, it can cost you like 3,000 to 6,000. It can vary depending on the amperage and the like phases. If a single phase can you can get it easily from 3,000 to 6,000. From a like if you go for a bigger company like Crompton, Snyder, Siemens, they can it will cost you like 6,000. But if you go for a smaller company like this one, the Select one, because it's a low current rate, it is only rated for 10 amps, so you can get it for 3,000, I guess. So anyone in the participant have the running a node, right? So I can share this data with you also. Please confirm anyone in the participant that they have a Node-RED running, so I can share the data with you. I can send this data to your computer also.
So dear participants, you can let us know all your queries in the chat section and the Q&A section, or else if you want to interact in the session, you can raise your hand so that we can unmute you and you can speak in the session.
Okay. And these dashboard you can also access on the mobile. Like, let me show you how how on mobile it looks. So you can see, if you are able to see my mobile, you can see this is my mobile phone. And I'm seeing the same dashboard on my mobile phone. I just have to enter the IP of my computer, and I'm able to see the same. Wait a second. Like this same dashboard on my phone also. So this is the dashboard that I'm seeing on the phone. If I turn the load again on, you can see we can also access it on the phone. So from the participant, if you have any questions, please feel free to ask. Like any question regarding the MQTT, Node-RED, Modbus, or any topics which I covered. I will share you the code and the flow for this Node-RED. So you can just export it, like you can import it. I will export the code from here. I can export this flow, and you can simply import this flow, and you will have this same dashboard with you. So participant, any query or question? I'm waiting for your queries. Like this hands-on is kind of complete.
Okay, thank you, sir. Thank you for this wonderful session. So we will shortly start with our valedictory session. The valedictory session will start from 2 onwards, 2 p.m. onwards. So until then, you can have a discussion with the expert regarding all your queries. You can, as we informed you earlier, you can post your queries in the chat and Q&A, or else you can raise your hands so that we can unmute. Thank you.
Okay. So, yes, sir, I will send the flow code and you can have a try with your own, but you will not able to get the data like because I will turn off this node after that, but you will be able to get this dashboard, and from here you can generate some random data using this inject one. Like you can use this inject tool to inject some kind of a data, and you can show it on your graph, like chart or graph you want. So any more questions? So that's it for today. I think there's no more questions.
Okay, thank you, Rishabh. Thank you, Rishabh, for this wonderful session. So we request you to wait for the valedictory session. So the valedictory session will start soon by 2 p.m.
So, ma'am, I got another link for the validity session. So I need to join with that link only, or is this
No
session?
issues. You can remain connected now. Okay.
Okay, ma'am.
Good afternoon, Neelam ma'am.
Good afternoon.
Good afternoon, ma'am. We are waiting for the other dignitaries to join. Once they join, ma'am, we will start the session.
Yeah, sure.
Thank you. So, dear participants, the link of the feedback form is already available in the chat box. So we request you to please give your valuable feedback about the program and also the scope for improvement. The feedback, the valedictory session will start shortly. So till the valedictory session starts, we request all the participants to please fill the feedback form of the entire program. Thank you. Welcome, Aridip Roy, sir.
Thank you. Yeah, thank you.
Yeah, so we will shortly start, sir.
Yeah. Okay.
Yeah, welcome, Kaushalendra, sir. We will start shortly once all the dignitaries join. Thank you. Good afternoon, Lava Bhargava sir. Good afternoon, Lava Bhargava sir. Can you hear me, sir? Lava Bhargava sir, can you hear me, sir? Good afternoon, Ratnajit sir. Good afternoon, Ratnajit sir. Sir, we can't hear you, sir.
Good afternoon.
Yes, sir. Now we can hear you. Good afternoon, sir.
Good afternoon. Good afternoon.
So, sir, we are waiting for Vinit Sahula sir to join, sir.
Great.
Okay, sir. Thank you, sir.
I'm not able to hear anything. Are you able to hear me?
Yes, sir. We can hear you, sir. Sir, actually, will Professor Vinit Sahula sir will be joining this valedictory session, sir?
Let me see, because if he doesn't have a class, he might join. I also have a class, so maybe I will leave after some time.
Okay,
I'll
sir.
just talk to him and let you know. I'll talk to him and let you know.
Okay,
Okay.
sir. Okay, sir. Thank you, sir. Good afternoon, Neelam ma'am.
Yes, sir. Aditi. Hello.
Yes, ma'am. Will Professor Ojha ma'am will be joining the session?
Let me confirm it with her. I'll let you know.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah, good afternoon, everyone. Should I
Good
call?
afternoon.
Yeah, should I call Dr. Manhas to join the
Yes, ma'am.
session?
Yes, ma'am. Sure, ma'am. Sure, ma'am.
Hello. Yeah, so I talked to Dr. Manhas. He said we should start the ceremony. He will join in between.
Okay,
So if
ma'am.
all the participants are free, maybe we should.
Professor
Okay.
Savla will not be joining because of other engagements.
Okay.
Okay, sir. Okay, sir. Thank you, sir. Sir, Ratnajit sir, then shall we start, sir, with your permission?
Please go ahead. Please.
Okay, thank you, sir. So good afternoon all. On behalf of all the organizing ICT academies at IIT Guwahati, NIT Patna, MNIT Jaipur, IIT Roorkee and IIITDM Jabalpur, we welcome you all in this final valedictory session of the online joint faculty development program on Internet of Things and Applications in Smart Systems, which was conducted from 14 to 25 February 2022. So first I would invite the principal coordinator of this program, Professor Ratnajit Bhattacharya sir, on the dais to address all the participants in this final valedictory session. Over to you, sir.
Thank you, Aditi. And good afternoon to everybody. So we have come to the end of this faculty development program on IoT and smart systems. And this has been organized through a joint effort of several academies. And we have the PI, co-PIs from the academies present here. I could see Professor Labhargava, Professor Meenakshi already present here. I hope the participants, they liked the organization of the course and the delivery by the experts from field, as well as we conducted hands-on sessions with the help of IoT Academy, and I'm sure this has been very helpful in understanding the theory part that has been covered. So valedictory session, usually we would like to hear from the participants. So Aditi, with these few words and welcoming you all to this valedictory session, I hand over this platform to you to invite our colleagues from other institutes and followed by some feedback from the participants. Please encourage them to come forward and talk.
Thank you, sir. Thank you for your kind words. So next, I would like to request Professor Lava Bhargava, sir, who is also joint principal coordinator of this program from MNIT Jaipur, to kindly address the participants in this final valedictory session. Over to you, sir. Hello, Lava Bhargava, sir.
You can go with Meenakshi madam and then you can come back to him.
Okay, okay, sir. So now next I would like to invite Dr. Meenakshi Rawat ma'am from IIT Roorkee to kindly address the participants in this final valedictory session. Over to you, ma'am.
So thank you very much. So first of all, I would like to congratulate all the participants. It was a very, very extensive program and they have covered so many topics. So congratulations on completing this program completely. And my congratulations to IIT Guwahati for organizing such an extensive program also. So actually, I wanted to hear something from participants because, I was not one of the lecturer here. So I was just wondering that how was the experience with the participants? Is it possible? Do we have few minutes to hear from the participants if they are here?
Yes, ma'am, absolutely. So dear participants, you can raise your hands. We will unmute you and you can share your verbal feedback with us. So we request all the participants to please raise your hands. We will be unmuting you so that you can give us a verbal feedback about the program.
So I can see Koteshwara Rao. Can you please share your feedback with us? Means how was this course and we could have done anything better?
Yes, ma'am. We are unmuting him. Thank you.
Very good afternoon to all the dignitaries present here. And I'm very happy to attend this program. My name is Mqtt, working as professor in Prakash Engineering College from Kandukur in Andhra Pradesh. So I learned a lot. Very happy to. I would like to make one suggestion, that is the cloud computing aspect. It need to be covered a lot, because the training should be such that every college must be able to maintain a cloud computer for themselves for doing experimentation. So, in order to have like that, the training should be including how to deploy a cloud computer, what are the technologies, what are the softwares to be installed, how the programming has to be done, some program, something like that. If it is included, it should have been very nice. Of course, in this 10 days time, it may not be possible. I request IIT Guwahati to kindly plan to conduct a separate FTP on cloud computer, its deployment, so, etc., etc., etc. Thank you very much for to have given this opportunity.
Thank you. Thank you very much. I think, yeah, we have, like you're saying, it was only 10 days. We could not cover each and everything. We tried to, but yeah, there are some aspects which can be covered. And I think IIT Guwahati is planning so many things in this field. And other ICT academies, they can also come together. So thank you for sharing your feedback. Definitely, we have noted down. It's a very important topic for the future also. So thank you for sharing that. Anyone else would like to speak something? It is good to hear from the lecturer from the place. I can see one Mr. Anurag Goswami.
Yes, ma'am. We are unmuting him.
Okay, hey, thank you very much for this such an interactive workshop. Spanned pretty well across different topics. Pretty well organized, actually. The documents and everything was pretty much all there on Google Drive. The one thing that I felt is the link of the drive that was shared on email. I have to kind of search every time. If you can use a URL shortener, that can be remembered very easily, so that I can access anytime, anywhere, right? So that it's in my mind. So that's what one thing that I felt. And congratulations to everybody who was there, and pretty interactive and pretty well knowledge disseminating session. So thank you very much once again, and looking forward for many more in the future. Thank you.
Thank you very much. Thank you very much.
Thank you very much for your input. So we are noting down all the feedback given by the faculty participants, and this platform has been created for this type of interaction. So it has to be interactive. It is just not a one-way dissemination platform. It has to be a two-way interaction, and then only we learn from each other. And I hope in future we will be able to conduct a complete FDP on cloud computing as suggested. I will pass this message to our PI of E&ICT Academy, IIT Guwahati, to organize such event. And Roorkee, Madam also may take up this, and we can jointly host.
Sure, sir. Sure. So can we take from Mr. Uday Prajapati? I'm sure that everyone is giving the written feedback. Anyhow, we will consider all of those. But right now, Mr. Uday Prajapati, would you like to say something?
Yes, ma'am. We are unmuting Uday, sir.
Okay. You're able to hear me, ma'am?
Yeah.
Okay, all right. So I'm basically from software engineering background. So I'm from industry. So I had attended the previous FDP also. So compared to the last one, I like this one much better because these were half days ones. So I mean that was one good thing. So you could balance between. I mean this is purely from working person perspective. So you could balance between both a little bit work and as well as the attending the FDP. I think it was organized very well actually. Okay, I think all the presenter presented it in a very well very the flow of the program and presentations, they were really very very nice. Okay. The hands-on, I liked it. Okay. Regarding hands-on, probably maybe I mean this is purely from means working person perspective. I mean maybe we can keep the hands-on on weekends. That's just one suggestion I have. And all the hands-on on weekends. So maybe on weekdays we get some time to go through all the material, and then on weekend maybe we are free to work with the hands-on. Okay. So that is what my feedback was. One thing I wanted was see the IoT. If in future we can have some presentations on real life bigger use cases. So I mean individual use cases are fine. These are the building blocks. But however, like how really they are being used in because in industry it won't be a very simple cases. They are complex use cases. So something on that would be really helpful. Yeah. And I really liked it, and I look forward to attending future FDPs also. Yeah. Thank you, organizers. It was a very job well done. Okay. Thank you very much.
Yeah, thank you, and thank you, Professor Bhattacharjee, for arranging such a good course.
This is my request to Mr. Prajapati, because since you are from industry, see, most of the experts were from the academia, and they always try to present this from an academic perspective. So what are the requirements in the industry, from which perspective we are looking at? If you can mention us, then it will be helpful for us to come up with at least few sessions industry specific.
Yes. Okay. All right. Yes. Thank you, sir. Yeah. I'll try to provide that feedback. Yeah. Thank you very much.
Thank you. So, sir, should we hear from other, organizers and lecturers? I think some of the views.
Yeah.
Thank you.
So we have some of the speakers present, so they can quickly share their feedback. We have heard the participants, and some of them, they are doing it for the first time. So it is very important to get their inputs also.
So, sir, I would like to request Dr. Argadeep Roy, sir, who was a speaker in this program from IIT Guwahati, to kindly address the participants in this final valedictory session. Over to you, sir.
Thank you. It was a very nice experience. I mean, along with the participants, I also learned many things, and it was a very interactive session. Therefore, I also learned in which areas participants are interested, and what are the things that excite them. So all the lectures, I enjoyed it to the fullest. One suggestion from my side is, since we are also learning through this process, probably the slides which are shared with the participants could be shared with us also, so that we also learn with the other areas whatever is happening, because some of us might be concentrated on a particular area of IoT, and all the areas may not be visible to us. So through these slides we will also be able to learn along with the participants. That is one suggestion that I have. Okay, thank you.
Thank you, sir. Thank you for your valuable feedback. So next, I will request another speaker from industry, Mr. Kaushalendra Singh Sisodia, sir, to kindly address the participants in this final valedictory session. Over to you, sir. Kaushalendra, sir, are you there? Hello.
Yes, ma'am. Yeah. Good afternoon, everyone. So, thanks to Ratnji sir, all PIs from different E and ICT academies and coordinators. So basically, I would like to take the comments that that was given. So one comment was given by Mr. Uday Prajapati regarding the real hands-on from the industries. So one point I would like to mention here, like already whatever the simple hands-on we conducted, people were not having proper hardware. So it was, we did not see the that much participation from the participants. We assume that they saw all the things, whatever concept we have shown, all the data capturing, acquisition, then the some processing, and even taking to the dashboard and displaying on the dashboard some analytics. So these kind of things they have understood. Some people have actively participated, but since the simple use cases, if we don't have hardware, we can people are not participating, then bringing the complex use cases and showing the real industry, that is not possible in the online mode. That is one complexity. We can share some videos, that is one possibility, but if we talk about the hands-on part, that is not possible in the online. That's what I would like to say. The remaining thing, if any other comments, we are ready to take, and we will try to check that what additional thing we can do for the real use cases. Like we could have added the predictive maintenance that was not there, that we are working, and that is very important. We would try to improve definitely, but there are some limitations that we have to understand. So with that point, I would like to conclude, and thanks a lot every participant for their time and trying to understand the concepts from the theory as well as the hands-on point of view. So again, I thanks to all the organizers for giving us opportunity to share our knowledge. So thanks everyone. Over to you, ma'am.
Thank you, sir. Thank you for your kind words. So next, I would like to invite the Joint Principal Coordinator of this program from MNIT Jaipur, Dr. Neelam, Triple ITDM Jabalpur, Dr. Neelam Dayal, ma'am, to kindly address the participants in this final valedictory session. Over to you, ma'am.
So good afternoon, everyone. First of all, thank you IIT Guwahati for organizing such a great event on such an important topic of current decade. And obviously, congratulations on the success of this event. I myself have attended so many lectures during this FDP and saw the diverse and rich content in these lectures that were being held. And thanks to all the participants also, because of them only this FDP got successful. And hope the participants have reaped the maximum benefit out of this FDP, and all the suggestions given by the participants will definitely be taken care of in future context. So that's all from my side, and best wishes to all the participants, and thank you so much.
Thank you, ma'am. Thank you for your kind words. So next, I would like to invite the Joint Principal Coordinator of this program from MNIT Jaipur, Professor Lava Bhargava, sir, to kindly address the participants in this final valedictory session. Over to you, sir.
Thank you. Professor Ratnajit, the guiding force behind this course, and other participating institutes and participants and the experts. I trust this course has turned out to be meeting what your aspirations were about this course. And I'm sure in future also we'll have such courses in other diverse areas. So keep a lookout for that. And thank you for participating in this course. Thanks a lot.
Thank you, sir. Thank you for your kind words. So with this, we come to an end to this valedictory session. So thank you all for joining this valedictory session. And lastly, from the entire team of ICT Academy at IIT Guwahati, we thank all the PIs, CIs, and all the principal and joint principal coordinators, the speakers of this program, and especially the participants for joining this program and making it so successful. Thank you all.
So on behalf of the coordinators, I would also like to thank our ICT Academy people who have actually worked tirelessly across all the academies to make this course successful. And I'm really happy to note that Finally, people have enjoyed this course, and all credit goes to our respected instructors, also our academy staff who has been working for a long time to make this event successful. Thank you, Aditi, for taking us through this course.
Thank you, sir. Thank you so much. So, sir, with this, we come to an end of this program and also to this validatory session. So, thanks all the participants for joining and making this program successful, and thank you all. So, there are a couple of announcements from our end. The attendance of today will be updated tomorrow, and certificates will be distributed from next week onwards. We request all the participants to please have a look on the drive link which is already provided to you. The drive will be uploaded some of the materials will be uploaded shortly. So we request all the participants to download the material at their end and save it in your local system so that you can use it in future whenever required. So that's all from our end. Thank you all for joining. Thank you all the dignitaries for joining this session and making this session so successful. Thank you all. So that's an official end to this program. Thank you all. So we request all the participants to please be disconnected. We will be deactivating the meeting link shortly. Thank you all. Thank you all for joining today. Thank you. Bye.